Good morning.
Okay.
Okay, so today we have Jesse Postma again with Postma Electrical and also Ask Environmental. So he's going to give us another run through of the electrical portion for the training today. So I'll give a quick preamble with codes and whatnot as we have been discussing this past week. So again, you guys are not required to know any of the codes that we've been talking about, but we always present them for your knowledge. So that way, if you guys are doing inspections on brand new buildings or say like basement developments, then you'll know what to be looking out for. So Jesse, I'll let you take it from there.
Okay. So as kind of what Alex said, you're not, everyone can hear me okay?
Yes.
We're good? Okay. As Alex mentioned, you're not required to know electrical codes being a home inspector. However, there is some real basic rules, things that you're going to run into that are really obvious and are, you know, things that should have never been allowed to begin with. But if you guys want to take down my information, so my name is Jesse Postma. My cell number is 403-358-9652. I'll put it in the chat for you guys. And then if you ever run across something that you're not sure of, shoot me a text. Don't call me, I won't answer. But shoot me a text and just snap a picture of it. And typically you'll get a response, you know, evenings, weekends, doesn't really bother me, but you'll get a response pretty quick as to, you know, whether I see a code infraction or not. One thing I should mention, the only person that I can tell who they're from is Gary. He's from Calgary. If you're outside of Alberta, there's going to be codes that are specific to your region. So BC has WorkSafe BC. They put out safety bulletins that are relevant to BC. Those types of things. So, and I mean, Alberta has a few documents that they post every year. They do updates to code. I mean, there's a multitude of different rules in different provinces. So I'm not going to be able to tell you all of them, but I can kind of speak to BC and Alberta. I am licensed in both provinces. I am capable of pulling permits. I own an electrical contracting company here in Alberta. I've had about 30 electricians working for me at one point, and I have 5 currently. I also own a hazardous material remediation company. It makes me slightly uncomfortable to tell you that I have worked with asbestos. Probably more so when I was an electrician than working in the hazmat side of things. So I'll go through a slide. We'll take some breaks throughout the day. I'm going to take a bit of an extended lunch today as I have an appointment at noon. And if you guys have any questions, please don't hesitate to ask. At the end of the day, I'll kind of leave the floor open, and if you've got questions in regards to something that we have not touched on or things that we have touched on, I would encourage you to ask. And I think that's pretty much it. So I'm going to kind of jump right into it. I'm going to open up the chat here just so I can make sure I can see. Alrighty. Okay, talking electrical safety. So again, I kind of briefly touched on it. The big book that we follow is the Canadian Electrical Code. You can get it in PDF form. You can get it in book form. I would recommend that you get it in a PDF. It's just really easy to reference if you need to. For the most part, the codes that you're going to run into that are an infraction are in the first section. You know, quality of work is an electrical code. Having permits is an electrical code. So again, that's really the things that you're going to want to watch out for. A really, really easy determination for whether there's a permit is a sticker. There'll be a sticker right on the panel. It's extremely common to not see stickers. Now, anytime there's an inspection, there will be a sticker. And that's in any municipality. So whether it's a hot tub install, there will be a sticker. Whether it's a basement development, there will be a sticker. Commercial tenant improvement, sticker. So it'll reference the permit number, it'll reference the inspector that performed the inspection. So again, that's something that's really easy, and it's right away going to be a red flag as to whether or not that installation was done to code. Okay, talking about electricity in and of itself. So voltage, current, and resistance, they're all related to each other. It's a science that you really don't need to know. But for the most part, voltage is, it's I guess the pressure in which is the force behind the actual power. The current would be like the water inside of the hose, and the voltage would be the force that's actually pushing that water through. And then resistance is the kinks in the hose, excuse me, any bends that it might have, somebody stepping on that hose. Sorry. They're all related to each other. And again, really the only thing that you should take away from this is that you're going to see multiple different types of voltage in a commercial installation. So you'll see things like 600 volt, 208 volt, 480 volt. The higher the voltage, typically the more dangerous an installation is, but it's current that kills you. So higher current, more danger. So when I say that, I mean a range or a stove is typically a 40 amp, so current 40 amp circuit. It's going to be a lot more dangerous to work on than a 15 amp plug. All right. That's really it for the science. That's all you really need to know. Most common electrical hazards are shocks and fires. For the most part, both of these are going to be caused by loose wires. So if you're getting a shock off, a water pipe, it's typically because of a loose ground. If you're having a fire in a house, or there is evidence of a fire, it's likely because there was a loose wire somewhere that caused arcing, which then caused heat, which then caused something to ignite. Recently, we were on a project where the drywaller was re-drywalling, and he put new drywall up. And when he was putting the new drywall up, he was pushing on a box that had a wire protruding from the wall. And as he was pushing down on it, it started arcing, and it actually caught the insulation on fire. Insulation doesn't, for the most part, light on fire. But if you put enough heat to it, it may start to ignite. So again, speaking about the Canadian Electrical Code, when you look at the purpose of it, it's to protect persons and property, primarily protecting persons. So again, the reason we have grounding in place, grounding and bonding, is to protect persons and property. So equipment, things like step potential is something that's becoming more relevant in electrical, and that's why grounding has become so important, and proper grounding has become so important, is to ensure that we're not killing people, and that we're not killing livestock, that we're not damaging pieces of equipment. So it's just really important that things are built to code, especially because this industry changes so much with technology and understanding the principles of electricity, that we stay current on on installation codes. So current preventing shock. Preventing shock number one, and I'll be honest, it's not personal protective equipment. Preventing shock number one is don't touch it. Then I mean, if you're not touching it, you're not going to get shocked. I know you guys don't typically work inside of panels. You're not required to open up a panel. If you are somebody that does, that's okay. But be conscious of the fact that, you know, you should be wearing, you know, boots. If you can get a composite toe, steel toe, so not, I guess, a work boot, I guess a composite toe work boot is going to be better than a steel toed boot when working with electrical. If you do intend on opening up a panel, that's your prerogative. Safety glasses is always a good thing. Gloves is always a good thing. Wear tight gloves if you're going to be working anywhere near live electrical, because loose fitting clothing, loose fitting gloves tend to catch on things. And then if you're planning on working in a panel or even opening up a panel, either remove your wedding ring or get one of those silicone ones, hang it on your neck. I wear a gold ring, and gold is one of the most conductive materials that there is. So I typically just remove my ring, set it to the side before I open up a panel. It's just good practice. Necklaces, again, if you're going to wear a tight-fitting chain, that's fine. But that's really up to the individual as to whether you're comfortable opening up a panel. And then use of testing tools, different testing tools. You know, we've got a tick tester. We've got a different type of tick tester. And then obviously an electrical meter. You're not required to have a meter. You can go to Canadian Tire, pick up a Mastercraft one. Most of our first year apprentices use a Mastercraft meter. It's inexpensive and there's nothing wrong with it. You don't have to go out and buy a $500 meter. That's just unnecessary. All right. So I guess to further touch on tick testers or non-contact testers and circuit analyzers. So this is a circuit analyzer. It's seen some days, clearly. It's got missing components. I should probably get this thing changed out. But I've had this since day one. And it's one of the very few tools that I've never lost. So this is a really handy tool. It's really, really simple. You plug it into the outlet. If it's a GFI circuit, you can press this button right here and it will automatically trip the GFI. Okay. Sometimes you'll notice when you hit it, you'll hear a click and the lights will go off, but there might not be a test or reset button. A lot of ways older houses were wired. We would put multiple bathrooms on the same circuit. So when you hit this and the lights in the bathroom go off, the lights on your plug tester go out, but there's no reset button, and now you're sitting here panicking because you don't know where the reset button is, it's likely in the bathroom, on the other side of the house, on a different floor, and then a simple just a reset of that plug tester, or sorry, that receptacle will rectify that. Exterior of a home required to have a GFI as well. Okay. Same thing, front and back of homes were typically wired together. Only one will have a GFI. Okay, that's pretty straightforward. It's got a little map. Not sure if you can, I'll kind of go as close as I can. It's probably reversed, which is sweet. But it'll give you a little map of, you know, whether it's an open ground, an open neutral, an open hot. Don't try and fix it if you see these issues. Just make a note of it, snap a picture of it, and include it in your report. So Again, this is just a little bit different. Okay, this one's got a map on the back of it, front of it, I guess, as well. Okay, it's got a GFI tester right here, and then a non-contact tester on it here as well. I don't use this one very often, or at all, to be honest. But so then this actually goes into the outlet, into the hole of the outlet. One thing you're going to want to note is a lot of times when you're checking for power at an outlet and you're using a volt tick, when you go to insert this in, if there is shutters or tamper resistant slides on the outlet, this may not get a proper read. It's important that when you enter this into an outlet, that both prongs enter in at the same time, or else you're not going to get a proper read. Some outlets are tough, especially newer, tamper resistant, the ones with the shades, so you really got to push them in. So we got our outlet analyzers. There's a pretty clear picture of, again, a little bit different than the one that I have. But again, it's has the same functions. Non-contact testers. One thing I should note about them is, again, if you're using it in this application, similar to, can you guys see my mouse?
Yeah,
you
betcha.
Yeah, okay. So if you see right here, if you're using it in this application, okay, the one downside is tick testers pick up any voltage, period. Small amounts of voltage, they'll pick up induced current, which is not helpful. You don't need to know what that means, but ultimately, when you're using a tick tester, if this is your wire right here, okay, stick your thumb like this and press it against the wire. That will remove any potential to read induced current, and it'll give you a true idea as to whether or not that cable is live. Obviously, you don't want to do this if the wire is bare, but if it is in an application such as this, in the picture on the left, just stick your thumb over it and then stick it like this, and you'll get a true reading. Because you may just stick it like this and it may buzz away, and then as soon as you put your thumb on it, it'll show as dead. And then a combination tester. So there's a few different stages in the last couple of years. 2015 code, and I think actually 2012 as well, required all bedrooms to have an arc fault breaker. So ground fault detects a fault between ground and hot, which is great for around water. Arc fault breakers detect between neutral and hot. And the intent behind them was they realized several years ago that that when people were moving things around in their bedroom, that they'd move their dresser, it would roll over the lamp cord. And when it rolled over the lamp cord, it would create a little bit of a short inside that lamp cord cable, and it would start to arc, and it wouldn't be picked up if it was on a ground fault. Excuse me, wouldn't be picked up if it was on a ground fault, but on an arc fault breaker, it would detect that loss of current inside the hot to neutral, and as soon as it detected that difference, it would then trip the arc fault. So this tool is meant for checking arc faults. Okay, it can check GFIs as well, but tripping an arc fault. Most situations that you're going to run into is it will be a breaker that has an integral like test and reset button. So if you are checking arc faults, make sure that you go down to the panel, turn that breaker all the way to the off position, and then back to the on position.
Maybe I'll make a quick note there, Jesse. So with all the tools that Jesse was talking about, guys, the two typical ones that most inspectors will have in their tool bag would be the receptacle, the outlet analyzer, and the volt tip. Yeah, you betcha. So if you are going to buy these tools, which again, very inexpensive, usually 10 to 15 bucks per, I would recommend to get a outlet analyzer that's got that GFI test function. You can purchase those combination AFCI, GFCI outlet analyzers and testers if you want, but like Jesse said, typically if the panel board has an AFCI breaker or a GFI breaker, you can just simply test the AFCI using the breaker test function. Like I said, those AFCI GFI combination units are typically fairly bulky. And like Jesse was saying, I wouldn't recommend buying the combination Voltic and GFI tester because it is fairly bulky and you don't really use the Voltic a whole lot. You might use it, a few times a week. So when you have that bulky tool, that combination unit, it may kind of impede your use or the speed of testing because you're going to be testing almost every single receptacle in the rooms inside the structure.
Yeah. And I
Sorry.
mean,
Sorry, Alex, I have a quick question for you. All the outlets should be tested by a GFI or just everything it looks weird?
Yeah, so
I can actually speak to that.
let me just make a quick note then.
Okay.
Definitely, Jesse. Yeah, so as per your standards, you're only supposed to allow or not allowed, but required to test a representative sample, if you will. But good practice is to test all the receptacles that you can. If there is bookshelves and couches in the way, you use your discretion because I would say it's probably best to take a photo and say, this receptacle was not tested due to X or Y, rather than possibly scratching floors or knocking over lamp shades and whatnot. But I would say I always try to do all the ones that I can without possibly moving things or causing damage. But your standard just says a representative sample, which of course is very, very vague. So even testing windows, you don't have to test every single one, but generally they say a representative sample.
And I mean, for what it's worth, the biggest ones I think are going to be the most important ones are going to be the ones that have a GFI. So anything, as a general rule of thumb, the code is 1.5 meters, but the best way to determine that is if you can stick your hand in the sink and you can touch the outlet, that requires GFI protection. Now, something to keep in mind is you'll notice that in a lot of older houses, they have split receptacles. So that means the top is a circuit and the bottom is a circuit. That met code at the time of install. It is very difficult to GFI protect those. It's possible, it's very difficult. And likely you'll run into that situation where you'll see an old style of receptacle, just a standard 15 amp instead of a T slot receptacle. And when you do, typically it is a split receptacle. It will not be GFI protected. You can pretty much bank on that. Before we move on to the next section, again, you can get a meter if you'd like one. Again, it's not necessary. It has multiple functions, voltage testing, all those different things. So, but again, not necessary. One of the benefits of the newer tick testers, I actually noticed this yesterday for the first time, because I have an apprentice that has every tool that you could possibly imagine. But some of the newer tick testers have laser pointers on them as well, which, I mean, it really has no application for us. But for you guys, that might be something to maybe look at, because again, it's just one tool that does multiple applications. So
yeah, and those laser pointers, guys, actually often typically have a temperature setting too. They're great for showing things to clients when you're doing your walk arounds, because your flashlight, of course, isn't as direct as a laser pointer. But yeah, absolutely, Jesse. And I mean, in those guys are still 10 to 15 bucks.
yeah, and honestly, Home Depot is your best bet. Because of the volume that they run, most of our guys are buying tools from Home Depot. So not one to support big corporations, but when you're trying to save money and run a business, that's the place to go. Okay, so grounding and bonding, I guess, are probably the most important thing in an electrical installation. Grounding means providing a connection to the earth, and it's typically only once in an installation. Okay, this can be done via a ground rod, which is just a long metal rod. It can be done via 3 ground rods, spaced, a meter apart in a triangle form and then tied together. It can be done via a plate. You'll likely never see this portion of the installation, but a lot of times you'll see a bare wire that goes to grounding, or a green wire that goes to the grounding system. And then bonding. Bonding is providing an electrical connection between all current and non-current carrying components of a system. Typically an electrical system. That being said, the gas line and the water line are 2 non-electrical components that require a bond. Okay, a steel box requires a bond. A light fixture requires a bond. A plug requires a bond. A furnace requires a bond. These all have the ability to carry current because whether they're metal or they're utilizing power. So it's important that there's a connection, an electrical connection between them all. Again, you'll run into systems where it's called the 2-wire system, and it simply is sometime in, I don't know, Alex, you might be able to speak to this a little better, but 50s, the 60s, where they just decided they weren't going to run ground wires anymore, bond wires. And so it's just literally 2 slots on a plug and no ground circle on the bottom.
Yeah, we'll have some photos here in a bit, guys. But like Jesse said, yeah, typically pre-60s homes, you're not going to find, the 3-slot receptacles, if you will, with the bonding conductor pin.
Again, shock hazard. If it looks unsafe, it is likely unsafe. Now, I guess I can kind of touch on this one. This one looks like it's seen some water damage. There is NEMA guides, which are really, really good tools for you guys. There's a NEMA guide to water damaged electrical equipment, and there's a NEMA guide to smoke and fire damaged electrical equipment. Both great tools, really quick reads. Most of the municipalities that we work in follow these guidelines. They are not a CSA guideline. They are a NEMA guideline. That's NEMA. And they're free online. If you can't find them, shoot me a text and I can get them sent over to you. All right. What do we want to just keep going? We'll just keep motoring through. So you're going to run into 2 types of electrical services. You're going to run into an underground service. Again, typically you won't see it. You'll see a riser conduit, and then you'll see an overhead service, which has overhead lines that come into a home and they attach to a mast or through an insulated bolt on the side of a home. They're both extremely common. Most municipalities are pushing more towards underground for newer developments. I mean, overhead services, older neighborhoods just tend to cause issues when you have big storms, poor truck drivers, whatever that might be. So, all right. So I'll kind of go through. Again, this is on the left here is a really common underground service. So you can see the conduit comes up, enters into the meter base first. So on the right side there, you can see it comes up. It has an expansion joint in it. Not all municipalities require an expansion joint. You'll find areas, I think BC requires an expansion joint. When you go way out east the other direction to the Maritimes, there's a lot of more expansion joint because you see the ground shift quite a bit throughout the year. In Alberta, we don't see a lot of shifting with the ground level, so most services don't have expansion joints. It's good practice, not required. So you'll see it'll come up, it'll go into the meter base, and then out of the back of the meter base into the home. You can see the 2 little conduits on the side. One is actually a data conduit. that could be Shaw, that could be TELUS, that could be, whatever provider, Rogers, that's in your area. Again, not really relevant to your installation, or sorry, to your inspection. And then the one immediately to the left of that, where you can see the little wire coming out of the bottom, that's actually the grounding, the system ground. And it's a really good thing to look for, just to make sure that it's present. Okay, we'll talk a little bit more about grounding later, because there is other types of grounding that you can do, but were more common in the past. Okay, underground services for homes, 120, 240 volt. Occasionally, you're going to run into 120 volt services. They're dicey. They're extremely rare. I think I'm aware of only one tiny little municipality in Alberta that has a 120 volt service. I'm not familiar with any other ones. You'll likely start testing things and be like, this doesn't really make sense, or it just, there's a lot of really strange things with 120 volt services. But for the most part, 120, 240. You'll know that by the presence of a range, a dryer that's not gas. AC units are a pretty good indication. You can get a 120 volt AC unit, but they're a pretty good indication that it's a 120, 240 volt system. Okay, supply service, it's a concentric neutral. What that means is it's got two service conductors that run through the center of a cable, and then it's got a neutral cable that's braided and wrapped around the outside conductor, or outside of the conductors. I'll grab a small section of concentric neutral cable and show you guys this afternoon. And then minimum burial depth. Again, this is really not something that you guys will be able to see or judge or include in your reports. But typically, depending on the municipality, the minimum requirement is 600 mils, so 2 feet. And then you can go up and down based on the area that it's crossing. If it's a roadway, if you cover it with concrete or treated boards, you can go more shallow. So there's a few different things to note there. So this is a great picture of a concentric neutral cable. Typically, when we see concentric neutral cables, there's actually two conductors, and then that copper braid wraps around both conductors. Okay, the most common one that you're going to run into is USB. Again, it's an extremely common cable. It's inexpensive. It's got aluminum conductors with copper strands around the aluminum conductors, and for the most part, it's common because it's cheap. So again, here's a few more pictures. This is a great picture on the bottom right. It's a really good picture of what we typically see. Now, most of the time, that cable that wraps around that neutral is usually made of copper. So similar to this one, but with aluminum conductors. And then it's just typically two. There's no ground. We create our own ground at the service. Overhead services. This is something that you guys will run into likely quite often. You'll see different components on different types of services. So you'll see the cable coming in. For the most part, if you can touch it, if you can jump and touch it, it's likely too low. That's something you can note in your inspections, is the height of that service cabling, because it is what we refer to as unfused or not fused. It is probably the most dangerous part of an electrical installation. It is an insulated cable, so it's not so much an issue of whether you touch it or not, but because there's no breaker or fuse, if it becomes damaged, it will continue to be live, and it will just continue to burn and arc and do those things. It's effectively a power line. Most often they connect to a weatherhead, which is via a mast. So the conduit will actually rise up past through the roof, and then it'll have a weatherhead. The purpose of a weatherhead is to make sure that there's no rain entering that service conduit and actually dripping down into the meter base and then into the home. Okay, and then there's this little loop right here. It's called a service loop. It's very important. If there's not a proper service loop, what happens is you get rain. The rain hits the service loop, and if it's not done correctly, either you're going to end up with water back into this conduit, as we kind of talked about, because water is going to go to the lowest point. As long as you've got that loop in place, when the water hits, it's going to drain to the bottom of this loop and then drip off, which is what the purpose of that is. Okay. You may not always see a mast. That's okay. You may see an insulated service bolt. So it's a piece of porcelain that screws into the side of the house, and it connects very similar to the way that a service mast connects. Okay. This is triplex. So this is the overhead cable. So this is the cable that's, oops. So this cable that runs from the pole to the house, or can be run from the house to a barn or a garage, or multitudes of overhead applications, is triplex. So this is a neutral supported cable. So that cable right here, the one that has the arrow pointing to it, that's actually the neutral. It bears all the weight of that overhead installation. So the shear strength of that cable is what it relies on. So what they'll do is they'll run that cable end to end. They'll actually go through a loop and they'll fold it back and then clamp it. And the whole service relies on the strength of that neutral cable. Again, if you see an improper installation, a lot of times it's going to be not properly clamped. And again, you end up in a situation where that service is likely not safe. If that neutral isn't properly clamped or strapped, or there's a multitude of different ways to actually joint that at the end. But if it's not done properly, that service is at risk of coming down. I mean, it could be simply by wind. In the center of that neutral, there's a steel cable to add to the strength of it. And again, that comes from two simple principles, where electricity typically runs on the outside of a cable or the outside of a conductor. A lot of the large overhead lines that you see when you're driving, the transmission lines that you see while you're driving down the highway, they're actually a steel cable with a very thin layer of either aluminum or copper on the outside. So they get all their strength from that center steel conductor. They get a copy of these, correct, Alex?
Of the slides, no, not these guys, but all these distances will be in the modules, so they will have those along with the other references.
Perfect. Okay. So these are all really important measurements. Again, I kind of mentioned it again is a really easy thing. If you can jump and touch it, and if you're short, if you can hit it with a stick, it's likely too short. Okay. Obviously, roadways are going to have a higher height requirement, and a driveway fits into a roadway classification. If you can park a car there, it needs to be at 4 meters. A sidewalk's 3.5 meters. A lower level of a home, 2.5 meters, so on and so forth. Okay, there is some leniency on this, but for the most part, these measurements are hard set. The 1 meter clearance from a window, that one is there's no exception to that. Because you're dealing with unfused conductors, they want to make sure that you can't reach out the window and touch those cables. There would be an exception if it was a non-operable, like bathroom frosted fancy window. There may be an exception for that, but it would have to be a pretty small window for them to exclude that from this rule. So a couple different point of attachments. That's that porcelain bolt that I was telling you guys about on the right side. Okay. And then on the left side, there's a porcelain bolt, which again is an insulator, and it attaches directly to the mast. If that mast is a very tall mast, and I apologize, I don't know the exact height at which it requires guy wires, but once you get to a certain height on that mast, it loses all its strength, its vertical strength. So you're required to have 2 guy wires that come off the back and tie to the house. If it seems abnormally long, just double check, or maybe note that it was a concern. So overhead to underground or underground services, you'll see on the left here, we've got overhead services. So this is really common on farms or acreages, where you'll have power come in through 3 or 4 poles, and then it'll actually come down the pole and go to a meter base. Okay, meter base on the right side there is a farm meter base. It's called a combination meter, and it is a meter combined with a disconnect. Okay, on a lot of acreages, what you will see is you'll see a 70 amp, a 60 amp, an 80 amp circuit breaker on the pole. These are installed by service providers. So again, depending on where your area is, could be NMAX, could be Fortis, BC, could be Fortis, Alberta, could be whoever, is in your area. But the thing to note is you may have a 100 amp service in your home. You may have a 125 amp service in your home, and the breaker on the pole is only a 70. That's not something that we concern ourselves with. The breaker in your home is a 100 amp breaker. It will trip at 100 amps. The breaker on the pole is 70 amps, but it's designed in such a way that it will allow you to exceed 70 amps for short periods of time. So this is not a true indication of the size of the service. It's a special breaker that has a delayed trip mechanism on it, where if it detects a short, so if someone was digging and they chop a wire, that breaker will trip. But if you exceed 70 amps for a short period of time, it's not going to trip. Don't rely on that number written on that breaker there to tell you the size of the service. You have to look inside the home. Okay, you can see here on the left, that's a perfect example of a weatherhead that's not been installed properly. Okay, so what's going to happen is it's going to rain. You're going to end up with rain inside there, and it's going to corrode the inside of your meter base. It's the last thing we want. That impacts the entire home's power. You can see on the right there, this is a good example of a drip loop that's not in place. And it's, again, you can kind of see where if the rain was to hit it, it would actually come down and then go inside that weatherhead. So even though the weatherhead is present, you're still going to get moisture getting into there. And then obviously, as I kind of mentioned, you can see the neutral cable. This is likely not triplex because this is an insulated conductor. And in triplex, the neutral cable is uninsulated or not insulated, but this has not been properly secured. So wherever this is coming from, it's not done correctly. Okay, a bent mast. So this is a situation where I think I kind of mentioned it may require guy wires. This service should be redone. There's really no unbending a service mast, but this should be one length of pipe. and it should be done with rigid steel conduit. Rigid steel conduit is very expensive. And I guess something I kind of want to, talk about or should talk about is you're going to find a lot of abnormal or concerning things from houses that were built long ago. What we're running into right now on new installs, so you may actually go into a brand new installation and find more issues on a brand new home because of the fact that we're seeing so many shortages on different parts. We're seeing shortages on PVC piping, we're seeing shortages on steel piping, we're seeing shortages on breakers and panels and plugs, switches, multitudes of different components. And this is going to lead to electrical contractors making things work. And that's a scary thought. But what it's going to cause is when you attend a site to do an inspection, you might find breakers that are mismatched. You might find someone supplemented a rigid steel conduit with a piece of EMT or thin wall conduit. Maybe they didn't use PVC and they chose to use a lighter gauge conduit. So things that we really need to be conscious of on newer homes is a literal lack of ability to actually purchase the correct materials, and you'll see a lot of concerning things on new installs as well as old installs. On the right there, you've got vegetation interference. For the most part, when you see a situation like this, it can be a simple call to the service provider. A lot of times they don't want you touching the trees that surround the power lines, and they'll come out for free and do a quick trim on the tree. Now, if it's a sub-service, so if it goes to a garage or a barn or whatever that might be, it's the homeowner's responsibility to make sure that these are unobstructed. The last thing you want is, we had a bit of a windstorm on the weekend, and we didn't lose any full-size trees, but took out the tops of a few of them. And last thing you want is, last thing you want is the top of this tree coming down, hitting this, and you're out for power for 3-4 days, whatever that might be. So proximity, again, this is a really good example of too close to a window. I actually know this house on the left. Yeah, so it's proximity to a window. You can see there's evidence of an older service here. So just this service, all in all, wasn't done correctly. It should have never been close to this window. There's a concern with height because clearly this is the top of the man door, and it looks like you could probably jump and touch this. So there's a lot of different things that are going on in that service specifically. Okay. And then looking on the right side, there is technically no code infraction on this picture on the right. Now there is codes pertaining to quality of work. There's codes pertaining to, ensuring that you're not going to have, excess moisture entering into electrical equipment. And this is just one where you might not reference a code, but you might just reference the potential for additional moisture. This meter base here on the right, it is rated to handle rain. It's rated to handle a hefty rainstorm. But when you've got all the rain on the roof running into this downspout, and then coming out of this here and dripping directly on the crack right here, common sense speaks to the fact that you're going to end up with excess moisture. And it's just something that you should note in your inspections. All right. I feel like I shouldn't have to say what's wrong with the picture on the left. But again, we kind of talked about it. You can see right here, it looks like on the far left, the actual neutral connection point has failed. And then it comes in and it looks like someone has done a fine job of securing it the red-green way. So I don't know that this is maybe a common defect, but again, it's just something that a good look throughout is going to be going to give you an idea if there's any issues with the service. On the right side, we've got deteriorating sheathing. So in electrical, we use multiple different types of conductors. We use something called RW90. We use T90. We use SOW. We use TW, and they all have different applications. Some are capable of being subjected to sunlight. Some are for direct burial. Some are for use in conduits. Some have high heat ratings. Some can be subjected to oil-based products, so can be routed directly through oil-based products. This is an example of improper use of cable or conductor. So this conductor was likely not the correct conductor used in this application. So this is a conductor that was not rated to be in direct sunlight and just deteriorates quite rapidly over time. It's really important because what happens when you lose that insulated sheath or that insulation around that conductor is you end up with a live exposed conductor. So in this specific application, likely if you were to squeeze your hand around that cable, it would just turn into ash almost immediately, or it would crack and break off. You know, again, a bit of a heavy windstorm or whatever that might look like would likely probably just cause that to break off in chunks, whatever that might be. So for securement, so you guys can see on the left here, so that's actually a great example of how the neutral somewhat should be secured. Typically we see it go through and then actually fold back and then get bolted again in this section here. But this insulator bolt, it looks like this has likely been rotted away and it should be re-secured, okay? This is the service that feeds the home, and it's really important that it's done correctly because again, it's unfused power, okay? That's a really easy fix. It's a couple bucks. Again, an electrician probably take him an hour to do something like that, okay? On the right side, we've got lightning arresters. I will be honest, Alex, I do not deal with lightning arresters. I know the principles behind lightning because we deal with it. I think personally that lightning arresters are a complete and utter waste of money. Lightning does not differentiate on height for every 10 meters. So if you're standing next to a 300-foot tower and you are 10 meters away, you are just as likely to get struck by lightning as that tower. We deal with lightning struck houses on the insurance side of our business. But I mean, the lightning arresters, I couldn't even tell you what the infraction is here. So I'm hoping you can, Alex.
Yeah, you legend. So I mean, like Jesse said, they're not typically found out there, but this is more of an image to show you guys what they are. In case you're ever doing like a rural acreage, they're kind of, you know, some people say they work, some people say they don't work. If you are going to check them, you might see missing bonding connections, where you might find some, you know, some of the attachment points are loose, or the actual lightning arrestor may be missing a few fasteners. You know, again, this image is just to kind of show you what they look like. Some people say the same guys that are selling door-to-door vacuums and books are also selling these lightning arresters. So
thank you. Again, I think they're a joke. Lightning, I mean, again, surge protection. I'm also not a fan of surge protection for that reason. I mean, I've seen lightning blow up surge protectors along with every power bar in a house. But anyways, that's just my opinion. So a meter base, again, things that you really want to watch out for. The one on the left is actually an extremely unsafe condition, for the reason that if you're moving that meter base, or if the meter base has the ability to move, maybe a homeowner decided they were going to replace their siding, so they just cut around it and then realized, oh hey, it just comes off the wall. What happens is, inside of this meter base, there's four jaws that are live, that have power in them. Okay. When you pull that off, or when it has the ability to move, that screw can fall back in through the hole if it's not at all secured. And when it falls back into the hole, it can actually fall and touch those lugs or those jaws inside of the meter base and cause a line-to-line short. It literally can explode the meter base. So it's really, really important that a meter base is properly secured, and that the screws are not loose, or, and I mean, again, in this application, if I saw this, I likely would not touch that. I might take my pliers, grab that screw and see it and give it a shake if there's anything loose. But again, I would likely just call the supply authority. So again, Fortis or whoever that might be. Okay. Oops. Sorry guys, skipping ahead here. You can see here, when you have a situation or an installation that does not have expansion joints, and the ground settles, you end up popping conduit out of the actual knockout of the meter base. Again, something you want to look for, because what happens with this is, again, if you get any shifting, you end up with cables that ride against the edge of that knockout, and they end up rubbing, and you could end up with a short. It's rare, but it's really important that that conduit actually sits right inside the meter base, so that you don't end up with damaged conductors. Clearance to gas vents and relief devices, 1 meter. It's really important that a meter base stays away from gas. A lot of times you'll see in installations, from a contractor's perspective, we'll actually run our stuff in the same, our lines in the same trench as a gas guy or a plumber, and then we'll actually split at the last 10 feet and have 2 independent trenches. Gas lines go higher than we do, and for that reason, it's really easy to split. But to make sure we have that distance between the two is important. Service ampacities. Again, we kind of talked about it a little bit on that farm service, where you'll see a 70 amp or a 60 amp or an 80 amp breaker at the pole. That's not how you judge a service size. Okay. Inside the home, there's going to be a main breaker on the top of the panel. It should have a number on it, whether that's 60, 100, 200. We've kind of done this weird thing where we had 60 amps services because houses were small. There wasn't a lot of plugs in the house. Maybe you had 5 plugs in the whole house. So 60 amps was really common. And then I would have to guess, but I'd say probably around 1970, 1980, they're like, wait a minute, everybody wants lots of things in their house. We want to add lots of plugs. We're going to have TVs. We're going to have all these things. We need to bump the minimum ampacity. So now they were looking at minimum of 100 amps. You'll find a lot of houses have 100 amps. There's nothing wrong with having a 60 amp because it met the code requirements at that time. But it's definitely something you want to note in your inspections, because it's something that could impact, future construction or future renovations. It may very well be unsized. Maybe they've had renovations and the service just didn't get upgraded. And then we went into probably about 90s to early 2000s, where larger homes were getting 200 amps, but we didn't have the energy efficiency that we have now. So a lot of homes went to 150 or 200 amp services, larger cables, larger panels. So again, you'll see a huge uptick in larger services. And then we actually have kind of come back down again. I don't recall the last time we did a 200 amp service. I think the largest one we've done in the last probably 3 years was about a 150 amp service. And the house would make you blush. So it's, I mean, again, we're coming back down in service size. Not really something that's important to note unless it's under 100 amps. Again, I suspect, Alex, you could probably speak to this, but this is something that you guys typically put in all your reports, service size.
You betcha. And it's just good practice to get into, guys, because once you get to a panel board, the first thing you want to look at is, well, one of the first things is the disconnect rating rate, like Jesse said. So 100 amp is minimum, and like we mentioned, 862 square feet is the minimum for the electrical code. However, most insurance companies, if you don't have a rating of 100 amps or more, will request that the homeowner or the potential homeowner, so your client, would upsize it. That's why it's really important to disclose that, if it's less than 100 amps, that the buyer or the new homeowner may be required to upsize it within a month or whatever timeline the insurance provider requires or gives.
Yeah, and I mean, for what it's worth, if your client's satisfied with a 60 amp service and their insurance company is pushing for it, I've told insurance companies often just to pound sand. If there's nothing wrong with a 60 amp service, it's not unsafe. It's small, but there's smaller neighborhoods with smaller homes, and maybe you have an older couple that's just looking to retire. There's no reason for that service to be upgraded, and it's one of those ones where you have the ability to put into your report that, in your professional opinion, a 60 amp service is not unsafe. It genuinely is not unsafe. It's small, yes, but it's not unsafe. Yes. So indications of a smaller service. A great indication of a smaller service is a round meter base. A round meter base is not rated for 100 amps. So when I say meter base, I'm not talking about the actual meter itself. Okay, there's a base that this clips into. If it's round, it's a 60 amp service or smaller. Okay, doesn't matter if it has this bottom box here or whatever, it's irrelevant. If it has a round meter base, it's 60 amp. Okay, something that you want to be conscious of. I'm just looking. I'll double check, see if I've got any. Something that you want to be conscious of is smaller surface conductors. Okay, I'll post in the chat. Do you have, Alex? Do you have service size to conductor size anywhere in your modules?
I'm not sure. You mean like the actual thickness?
Yeah, so like 100 amp service is a number 2 aluminum. Do you have that anywhere in your modules?
I believe so. I can double check right now as we chat, but I'm pretty sure we do.
Okay. Yeah, I mean, if not, I can post that in the chat. And it's just a really easy check. If it's a 100 amp service, it needs to have number 2. If it's a 400 amp service, or sorry, a 200 amp service, it needs to have 4/0. So it's a really, really easy check. But for the most part, 200 amp service cable is very large. 100 amp service cable is probably about the size of a highlighter. I mean, it's, again, if it's any smaller than that, if you're looking at this picture on the right here, that's a 100 amp service. That's an undersized cable. I can tell by looking at it, and it's going to be on a lot of older homes where you'll see undersized service conductors, and maybe all of a sudden there's just a brand new panel there. But the best thing to do, again, is look for a sticker. there's no inspection sticker, it likely wasn't done correctly. And there's a lot of stupid electricians out there that are willing to do a panel swap or a panel change with these conductors being in place. And these conductors are live all the time. They are the unfused conductors that come from your meter base. Possible indications of a marginal service or undersized service. Again, really easy. You can see it says 60 right here. That is a 60 amp service. That's a really, really easy way to tell. You're not always going to see that though, okay? You'll have to look for other indications, conductor size coming into the panel. Again, there's a couple different ways. Sometimes you simply cannot tell. I mean, the breaker may be rubbed off. It may be an older style main breaker and it doesn't have a number written on it. That's not uncommon. But again, you'll have to kind of piece together other components. So wire size, maybe the panel size, maybe the meter base, to try and get a clear idea as to the service size. But for the most part, it's not going to be that difficult.
To answer your question, Jesse, yeah, at 3.1 guys, you'll have just the sizing for 100 and 200 amps. But if you want to send something over, Jesse, by all means.
Okay. Yeah, I can send a couple things over the chat, just in terms of wire size, and then I'll see if I can grab at lunchtime. I'll grab some 4-aught as well as some number 2, so that you guys can see the difference between the two. Because it's quite a substantial size difference between the two, so it won't be difficult to differentiate them. So kind of again to retouch on grounding, most important part of an electrical installation, this is the connection with earth. That's it. Ground rod, it can be a plate, it can be multiple ground rods, it can be in situ, which is I believe that translates into in dirt. Am I correct on that? I actually don't know the answer to that, but I believe it just means in situation. Okay, I honestly thought it meant in dirt, but because the most common in situ grounding that we see is the main water line coming in through the earth, and it's a copper line, and you can tag that copper line, and that will effectively act as your ground. Again, very uncommon. You'll likely never see it in BC because you got, for those of you that live in BC, it's so rocky there that you're going to be pounding, the electrician is going to be pounding multiple ground rods in order to get a suitable ground. So, I mean, again, that's just something to be conscious of, that you may run across it. Again, in situ, again, I'm going to go with in dirt. In dirt grounding or waterline grounding is common on very old houses. Typically in areas that are outside of the main big cities. You're going to see them in small towns where you just use what you had. So ground rods, very uncommon to see a ground rod inside of a house that protrudes through the concrete. I mean, for the most part, they should be driven all the way down into the dirt, so you get the full length of the ground rod. As for the exterior ones, so on the right side, you have to space them evenly. For the most part, if we're doing multiple ground rods, we're doing 3 and we're doing them in a triangle shape. And every service requires a grounding electrode or a ground plate, ground rod. There's no exception to that. Ground plates, the most common form of grounding. is simply just a big steel plate. We wait till the foundation's done for the most part, and then just drop it in beside the house. And then they just backfill around the foundation, and that's the extent of putting in a ground plate. So must be completely covered. So it's dug in after the fact. It just needs to be well dug well down into the ground and covered. Some municipalities will require testing on the grounding system. Again, extremely uncommon. So see, in situ, in ground, these both go into the ground. So in situ grounding, in situation, again, I would argue that it's in dirt, is typically, for the most part, what you're going to see is you're going to see a copper or cast piping, water piping for the main water lines that come into a home, and you'll see it tagged like this. Okay, this is an acceptable method. The most important thing that you're going to note, though, is number one, if there is a water meter in between, so if there's a shutoff and then a water meter, or a water meter, whatever order that might be in, as long as there's a jumper, so a bond that runs from one side of the meter to the other, you've met both your bonding requirements and your grounding requirements. Okay. How's everybody doing? Just throwing info at you, like everyone's good? Everyone's
No
good?
questions so far, Jesse. So
No.
It's all
No
good,
comment.
Jesse. Thank you.
No comment.
Yeah, it's all good. It's all good.
Okay, perfect. We'll carry on then. I think we'll take a coffee at 9:30 because I love my coffee. Yeah. So again, you can use a well casing as a ground. I'll be honest, I have never once seen this done. It is an acceptable method, but I have never seen it done. The only reason I know that a well is a good ground is because typically when you have a lightning strike on a house, it runs right through the well casing and it blows up every single component of a well. So lightning likes it, so it must be a good ground, but it is acceptable according to code. Again, it's not common on newer homes. Ground plates, most common. Look for that conduit that runs straight down out of a house. It's typically a really small conduit. Yeah.
Actually, just got a question that popped up in my own mind, Jesse.
Sure.
We were talking with Francis on Wednesday for the HVAC component. Now, are you familiar with any issues coming from lightning strikes and like geothermal systems? Have you ever heard of any issues? Because these are obviously fairly expensive installations.
So I guess to kind of further elaborate on lightning strikes, they what would be the best word to describe it? They don't discriminate. We've seen everything from we just had a huge storm go through our area, and we've had one house where just the phone system, that's it. It literally blew up, like low voltage portion of the system. So the phones literally blew up. We've seen where the lightning entered through the roof in the living room, went into a light switch, went down, came out of an outlet in the basement, went through the concrete, so it blew a chunk of concrete out, went into the rebar, and then it also at the same time went into the well system because it made its way through the panel, blew the well controller off the wall, went into the well system, cables, went out to the well, went down the well, blew up the well pump, blew the well cap off. So, I mean, again, you've got a giant, water's a great conductor, and you've got a giant tube of water that enters into the ground. I mean, if I was lightning, that's where I'd go. But I mean, it doesn't, like I said, it doesn't discriminate. We've seen weird things where it just goes through the house and it just blows the caps off the light switches. All the light switches blow off because it tries to go through the light switches. But again, it I guess in essence, yeah, I mean, from a geothermal standpoint, it's again, that's a great grounding electrode. So I mean, I wouldn't be surprised at all. And it's not uncommon to see very similar issues in municipalities that are like way off from the rest of the big cities. So again, I don't know where you guys are all from, but there's a small town near Red Deer called Lacombe. Lacombe has super dirty power. They see a lot of fluctuations in power just because they're a smaller town. And the lines that come in see a lot of friction. So they see a lot of power surges and power dips. So it's things to be, again, conscious of. Not really relevant to what you guys are inspecting. But yeah, I guess just hopefully that kind of somewhat answered your question without overloading you with information.
Yeah, we're good.
Yeah, grounding conductors. Again, this is typically it's going to be a green conductor, number 6 for copper. It requires mechanical protection. Mechanical protection can include being run through the joist space of the ceiling, or can be run in conduit. It can be run underground. You can use aluminum, minimum number 4, which is a little bit larger. I have never once seen anybody do that. Again, it's acceptable according to code, but typically it's going to be a bare copper conductor. What you might occasionally see is a solid, like a single solid copper conductor. It's number 10 and it's undersized. And if you ever do any work in that house in the future, an inspector will make you change it. And the reason they'll make you change it is because grounding and bonding are the most important things in an installation. And that's just a safety thing. So, I wanted to talk about something else. I'll come back to it. That's okay. Panel boards. Make sure. I think we've got some pictures actually. Perfect. Okay. So talking on panel boards, couple things to note. There is the, again, we talk about it, the unfused side. So that would be the side that's above. The cables come in from the outside down the top here. They loop around and through and then tie into the main breaker. This point right here on the left of the main breaker, those are live, okay? They are unfused. Okay, you can turn this breaker off. These lugs right here are still live. Okay, and then you've got your actual consumer side of the service, or the consumer side of the panel. This is where all your breakers are. If this is off, the main breaker is off, all these are dead. This is dead, everything's dead. Okay, when this is on, these are live buses right here. Okay.
Maybe I'll make a quick note, Jesse. So like Jesse mentioned at the start of the presentation, guys, you're not required to remove the cover, the dead front from the combination panel board. It's up to you if you want to do that. It is an industry practice that most guys or most inspectors, because there are obviously female inspectors out there, that most inspectors do. So again, it's like showing up without a thermal imaging camera, not required, but kind of the industry standard. Now, what is not done by most inspectors is removing the actual service box cover. So you'll notice the image on the left, you have that top panel, then the image on the right where it's been removed. So again, I wouldn't recommend to remove the service box cover unless you really want to check for things like, say, you have a suspicion that it's a marginal service, less than 100 amps. Again, if you see any watermarks and corrosion, at that point, it's up to you if you want to look further. Typically, when you see watermarks and corrosion in the lower portion of the panel board, usually means you probably have some up top. So again, maybe over time, if you feel you have more confidence and skill, you may want to remove that service box cover to see what's going on. But at the same time, a lot of guys don't. And again, I don't blame them, because it is high risk, because it is unfused, like Jesse was saying.
Yeah, so I mean, again, is there any of you that would likely be opening up panels? Anybody want to speak up?
Do you mean the like the dead front, or from the actual service?
Well, both. I'm curious if anybody is considering or would consider opening it up. I guess I'll just kind of touch on it. If you guys do decide you're going to open this up, for the most part, when you open up the panel, it's going to be 6 screws or 4 screws or whatever that looks like. When I'm opening up a panel, I'll put a large portion of my weight on the actual panel cover, and I'll press into it. I'll take the top 2 screws off, the bottom 2 screws off, and then I'll actually take, depending on whether you're left-handed or right-handed, but I'll take that left screw out in the center. I'll put a bunch of weight on it. If you've got a partner that you're working with or someone that you're working with, that's great. Get them to hold it while you do the screws. Okay, put a bunch of weight on it and then pull that last screw out while you're leaning up against the panel. Okay, once that screw's out, set your drill down. So again, have something nearby where you can set your drill down or your screwdriver down on, and then carefully pull the panel cover top and bottom, pull it straight out. Don't tip it as you pull it out in any direction, left or right, up or down. Okay, pull it straight out. Same principle when you're putting it back on. Put it straight back on. I like to have the door open when I put it back on so that you can see where the actual breakers will fit inside of the panel cover. Okay. If you do decide you're going to open the top of the panel, again, that's your prerogative. It's not required. These are the most flimsy parts of the panel and by far the most dangerous. So behind these 2 screws, oops, what's happening? There we go. Behind these 2 screws, it's kind of hard to see here, but there's 2 brackets. There's a bracket that comes out and goes across and here, and that's literally the screw hole, and that's the screw hole there. That is literally all that's holding this from touching the back of the panel. Okay, it rests on the main breaker. It's got 2 plastic pieces that come down on the left and on the right, and then this, and that's it. Some panels will have little slots at the top that these fold into and then kind of swing down and in. But again, if you do decide you're going to pull this off, just be really conscious of the fact that these bolts or these lugs right here are live and are unfused. Turning off the main breaker will not protect you from that. Okay, that would be a messy explosion if it was to explode. Okay. What else do I want to talk about on this?
Hey Alex, do you take off the panel when you do your inspections?
You mean like the main cover, or
Yeah, just the main cover, not the service box.
Absolutely.
Absolutely.
Yeah, like I said, the only time I'd ever take off the service box is if I have concerns either with the marginal service or a possible water intrusion. Yeah, one thing you may want to do, before removing the dead front or the cover, is to use your volt tick, see if it's live or back of your hand. Usually guys will use their right hand for whatever reasons. Jesse, what do you think about patenting plastic covers instead of metal ones for conductivity?
Plastic covers. Oof. I've never seen them. I don't know why. It'd be a great idea, but I feel like if it was a thing that would be acceptable, it likely would be done already.
What
So
Yeah.
I honestly, I don't know why plastic covers aren't a thing. That's an odd one. I don't genuinely know that.
Yeah, Alex wants to capitalize. I like it.
Yeah, I mean, there's your $1 million idea right there. Yeah. So we got a comment here. This is how most panels were at the farm I was working at. I never felt safe. I know why. Can you elaborate on that, Garrett? No, maybe. This service here is actually, it's done quite well. This is not an unsafe example of a service. I don't see any particular code infractions. It's not the neatest installation, but it's not an absolute disaster inside the panel. Typically, the messier the panel is inside, the less care there was put into it. I mean, the more likely you are to run into something that's unsafe. But
Yeah,
again,
I'm sorry, I was on mute there and I was talking.
oh,
Yeah, I was working at this farm and there's some it was actually legal grow show, and but it was like going in a time machine from back in the 1980s. And when I was working there, it was all these panels were wide open like this, the electrical, and it was actually a
okay.
big reason why I've got into home inspection, is this
Yeah.
place was ready to blow up at any minute.
Yeah.
I
Yeah.
didn't feel safe one bit, and I was like, you're doing water, there's condensation everywhere, and these things, some of these panels were in underground, was it sea cans, and I just was like, I got to get out of here. This
Yeah.
is not safe. And they're brutal because like they were like this, but it was just it was sort of neat, but everything in this whole home and farm was jimmy rigged, and I know the guy wanted to sell it. I'm like, well, you can't sell this place. It needs to be bulldozed.
Yeah.
Right?
Fair
So
enough.
so yeah, I never knew. I always had a feeling that this wasn't right. So now I see it and I know it. So
Yeah.
that's good.
Yeah, and I mean, again, having that cover on it is something that an inspector, whether a fire inspector, home inspector, an electrical inspector, are all going to make sure that you have that cover on and it's properly on.
Yeah.
Panels are required to have a 1 meter clearance in front, which is extremely common in a commercial inspection, where you'll see like, I never need to get to the panel, so they put a pallet in front of it, or multitudes of other things that you're gonna run into. I mean, again, it's important that a panel has the cover on it, and yeah, I mean that's really all I want to kind of touch on that. And we'll all believe you, Garrett. It was a legal grow up. So
It
yeah.
was.
Yeah.
Right?
Uh-huh.
My buddy bought it and I said, you're an idiot, but oh well.
Yeah.
That's
Yeah.
what they all say, buddy.
Yeah. Yeah. He said you were from BC, and then we all just immediately didn't believe you. So
Actually Kelowna, so yeah, don't believe
okay.
me.
Yeah.
Okay.
Yeah, so we'll kind of carry on.
Thanks.
Talking about the top part here of the panel, the service entrance side. Something that if you decide you want to open it up and do a further inspection, there's something that's really, really important on this part of the panel. So on the top end of the panel, it is imperative, so important, whether this is a white cable, the bare neutral cable that comes in, whatever that looks like, it is so important that this neutral cable in this portion of the service has a direct connection to ground. Okay. It's ensuring that your neutral has a bonding jumper or a grounding jumper. It's giving your neutral a 0. Okay. It is absolutely imperative that this is the case. Okay. It's done several different ways. Okay. It's done just by a direct connection here. You can see that this comes in, it attaches to the neutral, okay, and then goes straight across, and then the ground cable comes in and literally ties right into the neutral, okay, and then it's somewhat difficult to see, but you can see there's a little piece of aluminum that runs from the can of the box of the panel and ties into this screw. The reason, again, is to give your neutral a 0, okay? Electricity is all about the difference between 0 and whatever voltage you're working with. It's the potential difference between the two, and that's why it's so important that you make sure that neutral is grounded to bring it to 0. Does that make sense? Someone just, I can't see your faces, but nod if that makes sense. Yell if it doesn't. Okay, if you do decide to open this up, look for this, okay? It's super, super important. And it's a really common code infraction. All right.
Did you want to take that quick break, Jesse? It's 9:35. Totally up to you. We can get past.
Yeah, let's do it. Let's do it.
Yeah.
What do we want to do? 5, 10, 15?
Yeah, we'll take a 10-minute break and we'll come back 1:45, guys.
Okay, deal.
The man is back.
All right.
Go whenever you are there, Jesse.
Well, let me share my screen.
Oh, I will make it the host. There you go.
Thank you. Okay. Before we get going, does anyone have any questions? Probably not, because nobody likes to talk. It's just
I have a question. I'm wondering what will happen if a receptacle that doesn't have a GFCI, test it, with the GFCI, tester. So what happens?
okay. Nothing. If I'm understanding your question correctly, what happens when you stick this
Yes.
into a GFI and then you push this button? Or
Yeah,
sorry,
that's-
if you push, sorry, let me rephrase that. So I'll talk about two scenarios. Number one, you plug this into a standard receptacle, just one in the living room, whatever, and you push this button, nothing's happen. Nothing will happen. Okay. Because it's not ground fault protected, and the ground fault plug is protecting from shorts to ground. Okay. So when you push this button, you're literally creating a little bit of a ground fault. Okay. If there's no GFI protection on that circuit, nothing will happen. Okay. So you're literally creating like a little arc inside this plug, and the circuit's like, I don't care. Okay. When you plug it into a bathroom receptacle and you press this, whether it's at the panel or at that actual outlet itself, it's going to trip. Okay. It'll just reset itself or test itself. All it's going to do is go click and it'll pop out that. Now, again, you might run into a situation where when you go to use this, it tests itself or it clicks and pops. Okay. It may not reset right away. Don't panic. Leave it for 30 seconds and just hit the reset button again. Okay. It might not reset in the first minute. Leave it, come back to it later on in your inspection, and then reset it. Sometimes when they get tested, they don't reset right away, and it's simply because they tripped on heat rather than on a fault, and it just needs to cool that device down. Okay. Does that answer your question, John?
Yeah, thanks.
Okay. Anybody else have a question? I'm gonna go otherwise. Let's do this. Okay. Again, put it in the chat if you don't want to talk. Otherwise, we're gonna continue. Okay. I'm not really sure what I want to discuss on this. Again, this is, you might want to take a picture of this one. It's a pretty good indication of, what's going to be extremely common when you go to an installation. Okay. In this picture, you've got conduits exiting both sides of the panel. You're more likely to see Lumex or just bare cables exiting the either side or out the back. Talking about the components of a panel, you've got your neutral bus, which again is more common on newer panels to run down the sides of the panel. Okay, your ground bus, it can be located either as one singular bus bar at the bottom. It might be little bus bars put throughout the panel. A lot of electricians like that because it makes a panel nice and clean. You're going to see obviously the circuit breakers, the main disconnect. You're going to have all your neutral cables. This panel in particular is actually missing its neutral bonding jumper. Okay, so that connection between the ground bus and the neutral bus is missing. Now, you might get away with it because it looks like, and this is only a picture, but it looks like this neutral bus is directly screwed to the panel casing. So technically, you might still meet that requirement. It's just very uncommon to see a neutral bus placed directly on the back of the panel. It's usually got an insulated piece of plastic behind it or a cover of some sort behind it, keeping it separate. Older systems. So again, depending on where you guys are from, you might run into this kind of stuff more often. This is a fuse. Okay, the actual fuse itself is this little twist-on, almost looks like the base of a light bulb, and it screws in or pushes in to the actual fuse panel. I recommend an electrician have a look at it. I mean, fuse panels technically are acceptable because they were installed at the time that they met code. Again, anytime you see a fused panel or anytime an electrical inspector sees a fused panel, they're going to require replacement. Okay, and that just comes down to safety. I mean, fuse panels are typically associated with knob and tube wiring, and the two of them, while still technically meeting code, would fall under a safety of an installation code requirement. So Pushmatic. Again, these technically meet code, but I think these ones actually lost their CSA approval. I don't know if you can speak to that, Alex.
Yeah, no, I think you're right. I believe the loss is just because they were quite problematic. And just like Jesse was talking about those fuse panels, guys, most insurance companies will require they be upgraded. So again, if you come across them, just disclose them to your client and put them in the report, just to recommend that the potential buyer contact their insurance provider before removing conditions in case they need to do a sub panel or panel upgrade.
Yeah. Okay. Oh, I guess I can probably speak to stab lock breakers. So stab lock is another type of panel. They're typically, I don't think you actually see any that were installed post probably like 2004, maybe a little bit earlier than that, 2002. And like Pushmatic, stab lock also lost its CSA approval on the breakers themselves. Now, what I will do is I will grab a couple for you guys again at lunchtime. I got a whole laundry list of things I'm gonna grab. But there's two types of stab lock breakers. There is stab lock breakers that are entirely black. They have a black body, a black handle, everything is black. Those do not meet, they no longer have their CSA approval. They don't trip, okay? And obviously the purpose of a breaker is that when there's a fault or an overcurrent or something like that, that those devices trip, okay? The way that Stab Lock, which is now actually owned by Schneider or Square D, the way they rectified this was they rebuilt all new breakers and they said, here you go, use these ones instead. They have a white body with black handles, or white body with a blue handle, white body with red handle. They're an assortment of colors, but white body meets, has CSA approval, okay? The other downside is if you do see a Stab Lock panel, include in your report that Stab Lock currently is discontinued. So you can't purchase Stab Lock breakers. You cannot purchase a new Stab Lock breaker. Schneider has, I don't know if it's temporarily or permanently discontinued production of them. But again, something to be conscious of, and largely due to, honestly, COVID and the shortages as a result of COVID. So something to be conscious of there. I'll make a note to grab you some Stab Lock breakers so you guys can see those. And then fuses. Fuses are great. I mean, again, when you are looking at an installation, fuses are, they're typically about 99 times of 100, they are one-time use. You overload that fuse, it blows, and it can never be used again. It is garbage. So that's the one downside to a fuse, okay? Fuses are still used in installations today. We're doing a commercial installation right now where we have a fuse to disconnect as a primary, okay? They're typically on larger services. It's not often that you see them in a house. I would be, let's see, this is actually a single phase service, and so is the one on the right. So these potentially could be a house. They could be like a rooftop unit inside of a commercial bay. Could be a sub panel in a commercial bay. But again, fuses, totally fine. The downside is that they're a one-time use. Okay. Panel boxes. You cannot have them in a bathroom. You can't put them in a closet. You can't put them in a coal bin, for all of y'all that has a coal bin still. I don't know. I imagine it's based on the fact that we used to have coal bins. In Alberta, we don't have coal bins ever. But you cannot have them in a closet. Okay. A closet is different than a cabinet. Okay. A lot of times you'll see panels installed in a bedroom, and then they'll have like a cabinet enclosure around them with just cabinet doors. That is acceptable. Okay. The intent behind that code rule is they don't want you hanging clothes in the same room that you, or in the same space that you have electrical components in. Just as a fire hazard. Wet locations, panels are not rated to be wet for extended periods of time. They could handle maybe some light dripping over a short period of time, but unless they've been affixed with a sprinkler hood, which is a little plate that goes across the top, they're not meant to be in wet locations, period. Not outside, not in, honestly, not in a grow op, because a grow op is going to create a lot of humidity. And that's something that you need to maybe be conscious of, when you're doing your inspections. Does it smell like marijuana? Has there been, an indoor greenhouse of some sort? Because you're going to have excess moisture in the air. Insufficient workspace. You're required 1 meter clearance. Okay. And it's 1.7 meters to the top breaker. Okay. And something again, so just be conscious of these things. This is a really easy one. It can be permanent or it can be temporary. And when I say that, I mean this bulkhead has impeded the 1 meter clearance of this panel. Okay. But if you set a pallet of goods or a shelf in front of the panel, that is also a code infraction. Okay. Unsuitable location. The panel board needs to be accessible. To be able to reset those breakers. In an attic space is not accessible. So, no permit. So again, this is a great example of, there's no sticker. Okay, there's no sticker on these panels. This is a brand new panel. It has no stickers on it. The installation's kind of messy to begin with. It's not likely an inspector's looked at this installation on the left. Okay.
Like a quick note about those permits. So, in your jurisdiction, they all range a little bit, but I would say good rule of thumb is typically 2000s and newer installations, you would have the permit decals. That's not always the case, right? So like with older installations, so if you get into a 70s, 60s, 80s house, 90s house, even if you don't see a municipal inspection decal, you shouldn't assume that it wasn't permitted. But obviously in your area, once you start seeing a trend of, municipal inspection decals, that's when you might say, okay, well, since the 90s or the 2000s or, mid 2000s, that's when my area, you can see a lot more safety codes officer inspection decals, and then you can say, okay, well, this is the era in my area that it became a prominent thing. There's a question here. Does the installation orientation of electrical panels matter? Can it be vertical or horizontal? I'll let Jesse take that one.
Yeah, absolutely. You can be upside down or I guess completely turned. You can have the main services coming in the bottom. You can have them in the top. As long as you're not 1.7 meters to the top breaker, you meet the requirements of that code. And again, that's not always from like the concrete floor. It may be a situation where it's 1.8 meters, but they've put a permanent step on the ground where as you approach the panel, you step up. Where you approach the step, you're standing on that step up, and then it becomes 1.7 meters. Okay. Improper screws. Okay. This is actually really important, and it's not thought of often enough, I guess. You can see the top screw has a flat end and a pointed screw, obviously being pointed. I'm going to go back a few slides here just to show you guys why that's important. Okay, so you'll notice when you're putting this panel cover back on, okay, the top screw, not an issue. This screw, maybe not an issue. The bottom one's definitely not an issue. But when you go to put the screw in on the middle right here, if it's got a point, all it's going to do is it's going to drill into whatever is behind there. If it's flat, it's going to push it away. If it's pointed, it's going to continue to I guess, screw into whatever's there. Okay. It may not be the biggest issue down here, but when you move up here and you start dealing with service cables, they don't give, they don't push, they don't move. They're typically quite taut inside of that panel space. So if it was flat, it's going to push it. Okay. But if it's pointed, you potentially could be screwing a pointed screw into a unfused or live cable, and run into potentially big issues with, an explosion hazard. So be conscious of that. If you pull the panel cover off and you have to put the screws back on, and a lot of times it'll be short 1 or 2 screws, And just make sure that you're putting the screws that are pointed in the areas where it's not going to affect you reinstalling that panel, because I'd hate to see you guys blow up a panel. Okay. Panel schedule. That's a code infraction. A panel must be suitably labeled. Okay. It's really important. For resetting breakers, you know, I mean, it's something that if it's inaccurate, you can get called on an inaccurate panel schedule. Most inspectors, when they come in, they want to be able to turn off the device that's labeled dryer and prove that the dryer has, you know, been turned off. Okay, openings in the side of panels. I think there's actually two code. Yeah, there's two code infractions on this one. So first code infraction is we've got holes in the side of the panel. Okay, these require fillers. Okay, so that's infraction number 1. Infraction number 2, this large hole down here. Okay, we've got a bunch of cables that have just been jammed in through this large hole. This requires a connector. Okay, anytime you have a conductor entering in to a panel board, a fuse box, just a standard outlet box, whatever that might be, a 4x4 box, it requires a proper connector. Okay, this is not acceptable. Okay, you'll see sometimes where guys will put in, they're called bushings, and it's just a little ring that clips in there, and it's plastic, and it protects the cable from being cut. But it is not an acceptable connector for entering into a device box. Okay, it has to either be a screw connection, a pressure connection, so that cable can't move in and out of that box. Okay, missing cable connectors. So again, this is another great example of just requiring you know, a connection or a connector. Sorry. So just missing a connector. On the right side, we've got unsecured conductors. Okay, really straightforward. It's going to be really easy to see. A cable must be secured. Okay, we kind of briefly talked on it earlier about having mechanical protection for cables. The mechanical room is kind of like the, I would say the unicorn or the exception to mechanical protection. The kind of the space around the panel is an area where somewhat off the record, kind of an unwritten rule where you can surface mount conductors and they not be mechanically protected and still have it meet code. It's kind of just an acceptable method, I guess. But other than that, you're required to have mechanically protected cables. So something that we talked about earlier, improper installation. So you can see in this application here, they've got the dryer next to this. And we talked, the main breaker, we talked about this earlier, and I'll go back again so you guys can see. Go way back again, just keep referring to this picture. So we talked about anything above this line has to be service conductors. Okay, you cannot have branch circuit conductors above this line. You can't have them enter in the panel above this line. You can't have them loop and go up and then back down above this line. You can't have them enter, go up, over, down, and back in. So again, with that being said, that would be why this is a code infraction. Okay, this panel was likely full and they saw this as an opportunity to use the space in the panel. The purpose of this space was when Nova or Cutler decided to create these panels, they were like, hey, we're going to make it really easy on electricians. We're going to make it so that they can put the main breaker on this side. So when the cables come in, they can easily tie them on this side. Or for those left-handed electricians or whatever it might be, we're going to make it so you can take this out, put it in on the other side, and then the cables can come in on the other side. So anything above this line right here is designed, is CSA approved, and is a code requirement that it must be service cables. It cannot be a dryer or any other load for that matter.
Would your service from your sub panels be okay from there?
Yeah, you betcha. Yeah, absolutely. So if this was a sub panel, this would be acceptable. If this was feeding a sub panel, it would not be acceptable. Does that make sense, Nick?
Yeah, I was asking about the feed to a sub panel.
Oh, no, that's not okay, because that is technically a branch circuit conductor. So on the right side, we've got water, rust, and panels. Anytime you have water in a panel, you've got metal components, it's going to rust. Rust causes heat because it causes arcing. Arcing causes, heat, fire. It's bad. That's why water in electrical devices is not good. Okay, that's a really unsafe condition because what happens is you end up with a situation where water is a good conductor, so it creates a situation where panel boards become live, other components become live, and it creates an unsafe condition even before opening a panel. Incomplete breaker installation. This might be because it literally was improperly installed. It might be because there's not proper panel fillers and it allows the breaker to fall inside of the opening. Something you'll find quite often, and something we're running into right now because of shortages is you'll find that you've got the wrong manufacturer of a breaker in the wrong panel. So it's a common electrical knowledge that a Siemens breaker will fit if you try hard enough into a Schneider panel. So, if you were in a pinch, you could effectively take a Schneider breaker and jam it into a Siemens breaker and jam it into a Schneider panel. And I mean, for all intents and purposes, it fits. And both are CSA approved. However, our code specifies that it is a manufacturer specification that Schneider goes into a Schneider panel. Square D, which is the breaker on the left, or the right, sorry, fits in a square D panel. Siemens fits in a Siemens panel. You cannot mix and match. And again, that's something that you guys will guaranteed run into often. You pop open a panel and you'll see one breaker that looks off. It's likely a different brand. That's a code infraction. Okay. Go backwards. Overheating. Again, this could be a loose connection, whether it's on the lug itself or on the cable itself. But whenever you have a loose connection, you're going to have where something's almost touching. You're going to get arcing across that distance. Okay. That's likely what happens here. The thing about electricity is it creates heat, whether it's properly connected or not. And whenever you have heat, you get expansion and contraction. Okay. With copper, it's not nearly as much as it is with aluminum. And so whenever we use aluminum in an installation, we use a substance called penetrox, or an antioxidant that prevents that large amounts of expansion and contraction. Okay, so something to be conscious of is overheating, and it will typically be quite obvious. And just so you guys know, like in an application like this, this cable is rated for 90 degrees Celsius. So this jacket here has seen an in excess of 90 degrees Celsius. So if that's any indication as to how hot that actually has been, I mean, it'll give you a rough idea. Again, common panel board defects. A panel board is not a junction box, okay? And because it is not a junction box, it is not rated to have junctions in it. It's not rated to have splices in it. You cannot put a moret in a panel, okay? Again, we have unwritten rules, one of which is a doorbell. A doorbell is the one exception, okay? That little transformer on the side here on the left, okay, it's going to have a black and a white wire that come off. It's the one that inspectors will just, you know, turn the other eye. But other than that, no morets in a panel, okay? Doorbells are kind of the weird exception to all rules. You can put the wires under a breaker, that another wire, it's called double tapping, and we'll get into that a little bit later. But you can double tap a doorbell. You can moret a doorbell. But outside of that, no morets. You should never see blue, yellow, any color inside of a panel. Oops. On the right side, you can see we've kind of talked about it. This is a perfect example of, you've got your service conductors coming in the bottom, which I mean is technically okay, but this panel should then be switched and turned upside down, okay? And all your conductors should be coming in the top of the panel, so they're not crossing the service conductors. So right now, again, if we were to go back, there should be a line right here across these two lugs, and the service cables should only be in this component of this panel. So this is actually a perfect example of this panel should be taken, swapped completely 180 degrees, and the service conductors would come directly into this breaker, okay? All these branch circuit conductors should then be coming in the top or the sides to avoid passing through where your service conductors are.
Yeah, let me ask a question.
Sure.
On the left, those double tappings, are they not defects?
Sorry, John, I'm having a really hard time hearing you. I'm getting a bit of feedback.
Double tappings on the left.
Double tap breakers?
Yeah, double tappings.
We'll touch on that a little bit later, but it just means that there is two wires on one breaker versus one wire for one breaker.
Yeah, I agree. But this connected here, is that not a defect? Is that accepted?
Alex, are you able to put your question in the chat, John? I'm getting some feedback when you speak.
Or maybe if you could speak closer to the mic, John. It is very
okay. Now, can you hear me better now?
It's a little bit better with the feedback, but if you just want to put your question in the chat, I'll just watch it come through, and then I can answer your question if that works. Okay. And then I guess simply improper use. I'm not really certain what the intent was here. Again, it's one of those situations. Oh, here came John's question. Those double tapping on the left. Are those not defects? Are you talking these white cables here, John? So the neutral cable, so these screws here in the neutral, okay. Yeah, so those are neutral cables. You are allowed, according to the manufacturer, to have 3 per screw. So whether that's on the ground bus or the neutral bus, 3 per screw. That is a refer to manufacturer spec. For the most part, you're not going to see any more in there because it's almost impossible to fit more than 3 in there, and it makes your panel look like a hot mess. Okay. When I say double tapping, I'm referring to only the circuit breakers. 1 wire per 1 circuit breaker. Okay. Again, it's something that you're going to see often. Okay. Double tapping is, well, I ran out of space, so I just threw it under another breaker. And that breaker already had a wire under it, but I figured it'd be fine. That is extremely common. So neutral
So not
cables,
allowed but common, Jesse. Sorry.
repeat that, sorry.
Not allowed but common is what you're saying.
Not allowed. It is a code infraction. It's not allowed but common. Okay.
Gotcha. Thank you.
Yeah. It's one of those ones where you know, it's you got a vehicle that'll fit 5 people, and you're like, wow, there's 6 of us. We'll just squish someone in the back because it's easy, and then we'd have to buy a bigger vehicle, and we're only going, you know, 3 blocks.
Yeah.
It's that situation where it's like, you'll get an electrician who's either lazy or maybe a little bit scabby, or whatever that looks like, and they're like, well, you know, there's no space in the panel, and it's, you know, it's an after-hour service call, and they just stab it under another breaker, or a homeowner does it. They add a circuit, and you know, they don't know, and they just.
Is that something you'd want to fix immediately or what?
Yeah, I would definitely note it in your inspection. It's a direct code infraction. It's not something that has ever met code. You've never been able to do that. There's some things, fuse panels, you know, different types of grounding, different types of cables that were, you know, even aluminum wiring, they were acceptable at one point, and therefore they meet the requirements of code. So whether somebody likes them, whether the insurance company likes it, whether the, you know, the inspector likes it, you know, whether it makes me cringe or not, it at some point has met code. Double tapping a breaker has never been acceptable, never once. It's not grandfathered into current code because it has never been okay. So if you ever see a breaker double tapped, which we'll get into, and I'll show some pictures of it. If you ever see that, write it down. Breaker double tapped, code infraction.
I'll add to that because this is such a sticking point. Like Jesse mentioned, guys, when you see the doorbell double tap, you will see it 99% of the time. So you can put in your report that it is, you know, likely a electrical code violation. However, it's a very common thing. Again, you may want to find out in your area how the municipal inspectors, the safety codes officers deal with it. You may be in an area where you have some pretty strict SCOs where they say not allowed, period, stop doing it. Or you may be in areas such as Central Alberta where the inspectors go, okay, well, it's 24 volts, it's very low voltage, it's not grounded, you know, not a huge concern. So find out which areas. Again, typically, I mean, it's not allowed, very common thing. It's your, I guess, judgment call as the home inspector, how big of a deal you want to make it. I would always recommend to disclose it, but again, maybe just not make a huge fuss about it.
All right. Okay, keep going. All right. So we're going to talk a little bit about, I guess, a panel box and how it functions. If you don't understand, please say something, because this is really important. I mean, again, it's not uncommon for electricians to not understand this, but when you look at a panel, you're going to see 2 phases. Okay, you're going to say an A phase and a B phase. This is a single phase service. Okay, so in a house, you have a single phase service. It is not actually a single phase, it's two phases. Okay, a red wire, typically, a black wire, and a white wire. So your red is your hot or your A, your B is your hot, your second hot, excuse me, and then you've got a white wire. Okay, so when we look at this panel here on the left, you can see that where the A is labeled, it comes down and shoots off to the right. That piece where two breakers would click in to that would be considered the A phase. Okay, B comes down and alternates and hits 3 and 4. Okay, so that would be phase B. Subsequently, we've got A and then B and then A and then B all the way down the panel. Okay, in a commercial installation, we would have A, B, C, A, B, C. So we would have 3 independent phases. Okay, so residential service, single phase service, actually 2 phases. Everybody, I can't see you, but just nod if you understand. Okay. Now, referring to the picture on the right, okay, this is really important. So you can see the red is phase A, blue is phase B, so they alternate. Okay, when you're looking at the breakers, the top breaker in phase A is a single pole. So that comes off and feeds the fridge. Okay. Subsequently, we've got what's called a tandem breaker, and a tandem breaker is 2 circuits, both coming from the same phase. Okay. So this could feed the washing machine, and this could feed, I don't know, maybe one of the bedrooms or the bathroom or whatever, the lights, doesn't really matter. Okay. Then we alternate back to phase A, then we're back to B again, and A and B. Whenever you have a 240 volt load, okay, so a dryer, an electric dryer, an electric range or stove, a hot tub, a lot of times an AC unit, a sub panel, okay, you're going to have what's called a 2-pole breaker, and a 2-pole breaker must cross this phase line. It must be on phase A and phase B. If it was only on phase A, you would only have 120 volt, okay? Because it's on phase A and phase B, you have a 240 volt capabilities coming out of this breaker. Does that make sense? Does it not make sense? Give it a second. We carry on. Does it make sense?
I feel like I've nodded my head like 35 times so far.
Perfect.
And you can't even see me, so it's just really.
Okay.
Anyways.
Excellent. No, I'm glad. I want to make sure it makes sense because it's relevant to a lot of the stuff that we talk about coming up. So I just want to make sure that we're not missing any concepts. And if there's any, please don't hesitate to even just say no in the chat. I have no issues re-explaining it now. We can re-explain it at the end. So don't hesitate to say something.
This is the safe zone, guys. This is the safe zone. So
yeah,
best task now.
Well, I might like briefly make fun of you, but that's okay.
There's
I could hear it again if you got a chance.
Sorry, what was that?
I could have it explained again.
Okay.
Yeah, my brain's hurting, so that means I need to hear it again.
Okay, no, fair enough. Okay, so there's no such thing as a single phase service. So when you talk about a house A house is,
Jesse,
it's,
maybe go back to the image where we have the service cover off, because that's going to show you phase 1 and 2, or phase A and B, and you can kind of explain, the 120 volts, how each one produces
Yeah,
that.
okay,
combined.
yeah. I'm gonna stay on this one for a second and just kind of touch on the AB. So a house is, in layman's terms, it is a single phase service. So it has, it's just, that's what it's referred to as. However, it is technically 2 phases. It's phase A and phase B. So if we were to take phase A and hook it up to a light, and then tie a neutral or a white cable to the other side, we're going to end up with 120 volt. Okay, so if I were to put a breaker on the picture on the left, if I were to put a breaker in that number 1 slot, just a single breaker, I would have 120 volt from A to neutral. So I could run lights, I could run plugs, I could run the fridge, the gas, fireplace, whatever that might be. And a bunch of different loads. The majority of the loads or the pieces of equipment in a home run off of 120. Okay. Now I could do the same with B. I could put a single breaker on, slot number 3. Okay. Tie a black wire into it, and then take a white wire, and I would have, in theory, I'd have the exact same thing. Okay. Now, if you were to take your meter and you were to put one of the leads, like an electrical meter, and you put one of the leads on phase A and one of them on phase B, okay, so one on this breaker up here and one on this one right here, you would actually read 240 volts. Okay, we utilize 240 volts for things like an electric stove. We use it for an electric dryer, hot tubs, some well pumps run off 240. There's a multitude of different loads, but in order to get 240,
You need both phases.
you need both, exactly, you need both
Okay.
phases. So in order to get both phases, you have to have a breaker that crosses and touches phase A and touches phase B. So it has to be clipped on to this little bracket here, but it also has to be clipped onto here. And the only way to do that is with one of these little bad boys here.
Yeah, okay. Yeah, that makes sense. Yeah.
So it's all wiring orientation basically for your 240 then.
Correct. Exactly.
Perfect.
Right. And a lot of loads are going to be 120, 240. So like a stove is actually 120, 240. So the top of the stove uses 120 volts and the oven uses 240 volts because it needs that extra heat. Okay. So that's where you have phase A, phase B, and then they run a white wire or a neutral wire as well. And they pull off of, phase A and run the top of the stove. They run off phase B and they run the clock on the stove. And then they use both A and B to get the 240 and they run the oven with the 240.
Right.
Amir, does that make sense?
Yeah, good, thanks.
Okay. Is it all right if I call you Amir?
Yeah, it's short. Yeah, it's fine.
Okay. All right. So branch circuit. So again, this is a great example. This is a single pole breaker. Okay. This is a breaker that's going to give you 120 volts. So if we go back to the previous picture here, and I show phase A on the top left here, that's a single pole breaker. Okay. This is a tandem breaker. So all it does is it provides two independent 120 volt circuits. And then when we've got this bridge here that crosses the phase line, you end up with 240 volt. Okay. So there you go. 2-pole breaker. It's got that bridge that goes across. Okay. Again, very important. That's how you get your 240. Okay. 240 volt loads will have three wires, excuse me. They will have a black, a red, or two blacks, one that will attach to the one side of this 2-pole breaker, one that will attach to the other side. You'll have your neutral that goes to your neutral bus, and you'll have your bond or your ground cable that goes to the ground bus. Okay. So here again is an example of a bunch of different 2-pole loads: electric range, electric dryer. Most of the appliances that are gas only need 120 volt just for an igniter. That's all they do. Igniter, maybe a fan, nothing crazy. Everything else is gas. Okay. AC units, hot water heaters in commercial applications, because they're not used for showering or those types of things, are typically 120 volt. Hot tubs, most always are 240. EVSE can be either or, and a feed to a sub panel. Okay, this is why it is important that you understand the phase gap. Okay, this is a Federal Pioneer stab lock. Okay, so we talked about black breakers, black handle, black body. These bottom breakers are not CSA approved anymore. These top ones, white body, blue handle, white body, black handle. You see a little bit on the left here, white body, red handle. Those are newer federal breakers and have CSA approval. Okay. Now, when we're talking phases here, you can see 1, 2, 3, 4. Those make up phase A in this panel. Okay. 5, 6, 7, 8 make up phase B in this panel. Okay. 9, 10, 11, 12 make up phase A. So we talk about that phase line or that phase gap. That is indicated. We'll lose my mouse here. That's it. There we go. What's going on here? That's indicated here as this line that's between 3 and 5 and 4 and 6. That's an indication as to where the phase has changed. So this section here is A. This section here, from this line to this line, is B. This section is A again. Okay. And the reason that's important is because this garage right here is meant to be a 120, 240 volt load. They want to have 240 volts to this garage. Okay. The downside is it's been an improper installation. And the reason it is an improper installation is because both breakers have been installed on the A phase. So if I were to meter this on the other side, there would actually be no 240 volt because they both come from phase A. So this is not technically a code infraction. This is scientifically, it's impossible for them to have 240 volt in the garage. It's just an improper installation. This is not uncommon for electricians to not understand this. If you don't get this concept, don't feel bad, because it's a very difficult concept to understand. The fix for this would be to install a 2-pole breaker and have it cross a phase line. So 1/2 would be on 10, 1/2 would be on 8. So you end up with 120 volt out of phase B and 120 volt out of phase A. And then because you've crossed that line, you can run 240. So if they had a 240 volt welder in the garage or a 240 volt compressor in the garage, it wouldn't work in this application. So it's nice because they've run the wires, but it's not going to have 240 volt. I'm hoping that makes sense. Again, very difficult concept. Do we need 240 volt in the garage, John? No,
Yes.
You don't. You don't. But again, I don't think I've ever wired a garage that didn't have 240. I mean, people want to have a compressor. A lot of compressors are 240. Some people want to have the ability to use a welder. A welder is 240. Again, Alberta, it's really common for, people to have, hockey families. We've seen dryers go in garages. You can dry your hockey equipment. Again, it's more just, it's still, regardless of whether, you plan on having 240, it's still it actually becomes a safety concern. I'm going to try and share the information with you without confusing you. Okay, so the reason that this is a big issue, and again, I'm going to try not to confuse you guys. So if you have a 3-wire system, so one that goes out to a garage, it's tied onto a 2-pole breaker, power goes out on the black, right? And it comes back on the white. So let's say there's 15 amps of power running out on this black wire and it comes back on the white wire, okay? And then we've got 15 amps going out on this red wire and it's coming back on the white wire. If they're on alternating phases, if you dig down into the science, it's alternating current and they alternate opposite each other very fast. It's like 60 times in a second. But because they're alternating, this white wire only ever sees at the very, very most, this white wire is only ever seeing 15 amps. But what happens when you do this, that white wire has the potential to see 30 amps of power, and it's only rated for 15. So it's just going to burn up if it ever sees that, amperage running through it. So it becomes a bit of a safety concern in that front, where you're going to end up burning up the neutral cable. You end up with unsafe conditions on the neutral. It's just, it's something to be conscious of. And to be honest, I'd be super impressed if you guys caught this, because it's a really, number one, it's a really difficult concept to understand. It's not very, very common because it's typically homeowners that are doing their own work or electricians that simply don't understand. But again, we can discuss this a little bit more in detail if you guys want more information, but we'll discuss it later on. Because again, is it something that you really, really need to understand and know? I mean, it's good to have a basic understanding of it, but it's not imperative that you know this information. So, black and blue breaker, nothing. Blue is 15 amps, black is 15 amps. It's just the year it was made, or red is 20, green is 30.
Gray is 40. Gray.
Red is 40.
Great.
Thank you.
Yeah. I wouldn't try to memorize the colors, guys, just because, like just said, the era, the manufacturer. It's best to actually read the number. And sometimes you'll notice on these two images here, the ratings are extremely prominent. Other times you may have to look either to the left or to the right of the disconnect just to see what the actual markings on the unit.
Yeah, and most breakers are labeled.
And if they're not, you should definitely point it out, because again, you won't know if the breaker's only rated for, if the breaker say is rated for 40 and the conductor may be only 14 gauge or 12 gauge, which we'll talk about here really quick.
Yeah. Double lugging or double tapping. Again, something that we kind of briefly touched on. This is a really great example. This is not okay. Again, you can put neutral, 2 neutral cables or 3 neutral cables in a neutral screw. You cannot put more than 1 cable under, a breaker. Okay. If it's a doorbell transformer, it's kind of one of those unwritten, it's just been accepted over time. I don't know why. Can't answer that. It's not necessary to call that. But anything outside of that, if you see a double tap, it's really common on full panels. So you open it up, and it just kind of panel springs out at you because it's so full in there, you're likely going to run into double tap breakers. Okay, breaker too big. I'll include wire sizes in the chat as to what you're looking for. But again, if you've got a copy of the electrical code book, I think it's table 2 or table 4, indicates wire size. Super easy. I'll put it in the chat.
Module too. We got them in the module. Yeah, there's gonna be a screen coming up here as well.
Perfect. It's in the module, so that'll kind of handle that for you. But that is an undersized cable. Again, the problem with that is you end up in a situation where you have a potential before the breaker trips to run 40 amps through that cable that might only be rated for 15 amps or 20 amps. So it has the potential to melt that cable.
Make a quick note, guys. If you'll notice that the image on the right where we have the conductors on that 40 amp dual pole breaker, those are single strand conductors. We're going to talk multi-strand here really quick, but anything bigger than 30 amps should be multi-strand conductors, right? So when you see that 40, you only see the one solid thick copper wire. That's an automatic, interaction, just because it has to be multi-strand for 40.
Scorching, again, could be due to a loose connection, could be due to a broken wire, whatever it might be. It's caused an excess amount of heat on that breaker and it needs to be replaced. Okay, this is a great example, you guys, of a 240 volt breaker. Okay, so you can tell right here that this is the phase gap or the phase line where we switch from A to B. Okay, so we've got A, B going down that panel. Okay, so this 40 amp breaker is meant to be a 240 volt breaker. Okay, the code infraction or the concern that we have here is the bridge that causes both breakers to disconnect or shut off or trip at the same time has been removed or damaged or whatever, but it's not there. This piece right here, the common trip strip or the bridge, is completely missing. Okay, it's required to be on this breaker here. We want both phases to trip at the same time. Okay. Faulty test mechanism. Again, that's a GFI or an arc fault. You should be able to press that and the breaker will move into the tripped position. Okay, it's really easy on new panels to tell where the tripped position is because it's typically about halfway in between. Okay, so a lot of times you'll hit that, it'll go to the middle. Okay, I'm hoping all of you know this already, but when a breaker is tripped, it is in the tripped position. There's 3 positions in a breaker: on, tripped, and off. When a breaker is tripped, you need to take it, you need to move it all the way to the off position and then all the way to the on position. We get a service call once, probably every 2 weeks to a month, where someone's like, the breaker just shut off and I cannot figure out how to put it back together. And it literally is us going out to site, turning it off all the way and then on all the way. Again, if it doesn't reset right away, let the breaker cool for a bit. Don't panic, then come back, turn it off, and then to the on position.
Correct me if I'm wrong here, Jesse. Not the first note, but the second note. But the first note, some manufacturers, again, they may not have that center spot. They may just go on and off. But I believe that the actual pole does not have to slide to the off position as long as it trips. That is considered still fine. The lever is typically generally an indicator what position it's in. But as long as the breaker actually shuts off, it is still, I guess, a functioning device.
Yeah, and I mean, you'll look at again breakers like stab lock, where they don't go into the off position; they just become loose. So when you trip an arc fault or a stab lock breaker, it doesn't necessarily move even, it just becomes loose. So most breakers are either firmly in the on position or firmly in the off position. A stab lock trips, it just becomes loosey-goosey, and you can take it and you kind of like wiggle it. Okay. We talked about aluminum wiring. Again, aluminum in and of itself, I think we talk about it a little bit later as well. But aluminum wiring in and of itself is safe. Aluminum wiring is safe. There's this preconceived notion out there that aluminum is terrifying. It causes fires. It's this big, scary thing. Aluminum is safe. The connections are unsafe because aluminum expands and contracts more than copper does. It makes it unsafe. Okay, so if the connections have been redone or if they've been done properly, aluminum is just as safe as copper. Okay, part of dealing with aluminum cables is using an anti-oxidizing paste. So Penetrox, there's a multitude of different brands, but again, you can see in this application here, this breaker is rated, it's really difficult to see, but it says CU/AL. That means it's rated for either copper connections or aluminum connections. So either or is acceptable.
So they're not used very much now, Jesse, the aluminum wiring?
Never.
On today's date? No.
Never. Service conductors, we use them. You're finding stoves right now are using them because of wire shortages, along with shortages on everything else. Services, a lot of services use them.
They're fine solo, right? Like by themselves, as long as they're not with any other wiring. Is there a heat, like a big heat conductor, correct?
Well, they don't necessarily conduct heat. They just expand and contract based on heat. So anytime you use an aluminum circuit, it expands and contracts, right? Because electricity creates that heat. So in a situation like this, on a really minuscule level, that aluminum conductor is, say, this is the diameter or the actual conductor itself. And when you turn on the lights in your house, it does this throughout the day, right? And this is on an extreme level, but it does this throughout the day, right? So when it's inside of a moret or wire cap or under a terminal, so this breaker, it's doing this all day. And if you think of when you have a screw and you don't put a lock nut in there, eventually that screw works its way loose, and aluminum does the same thing. It works its way loose over time. The last time I think we used aluminum was in the 70s. And so we're starting to see the effects of that more so now, but we saw it late in the 80s, the 90s, where they're like, well, hold on a minute. These connections are becoming loose, and then they're arcing because they're not a tight connection anymore.
That's why, okay.
And now we're getting arcing, and then we're getting heat, and then we're getting fires because of aluminum. So an insurance company will say, no, you need to pull it all out. You need to rewire your whole house. And there's multiple options that you have for dealing with aluminum wiring, and we'll touch on that later on. But again, specifically when you terminate aluminum, so when you tie it under a breaker, under a lug, under anything, you're required to have anti-oxidizing paste, and that prevents or minimizes that expansion and contraction inside the connection.
Yeah.
Correct. You bet. Aluminum, safe. Connections, if done incorrectly, or if they're the original, unsafe. Okay.
Hey, Jesse, on that last, on the one, the back here, back one. The breakers that are on the left-hand side there, are they all the stab breakers?
Those are Cutler hammer. So the left ones are Cutler hammer.
Sorry, it's one page ahead of that.
This one.
No, back. Right there.
Yep.
So the ones on the left. What kind of breakers?
Those are Cutler hammer.
Okay.
Those ones on the left, those are stab lock.
Okay. I was just
Those are-
going by the black on black kind of situation and just trying
Yeah,
to decode.
and it's specifically, you'll notice, like, you'll see that these ones say Eaton.
Okay.
On the right side, it says Eaton right along here. And then you can see it says Cutler Hammer.
Yeah, okay.
And then this one actually says Westinghouse. That's what that W is down here.
Yep.
Westinghouse, Cutler Hammer, Eaton, all the exact same. Okay.
Okay.
Westinghouse is the oldest. And then at one point it was actually called Novaline. Novaline, Westinghouse, Cutler, Eaton. This is actually a great picture because it shows all the different brands that Eaton has ever created. But they are all acceptable inside this panel. It's just an age thing. So you don't see these type of breakers on the left anymore. You see these on the right. You see Eaton and Cutler Hammer. Okay. On the right side, it's hard to tell, but right here where my mouse is, it actually says Stab Lock, and it's spelled STABLOK. So it doesn't have a C in the word lock. Okay.
Right.
They all are super thin. So comparatively, they're like quite thin breakers. Okay. They're about the thickness of a pencil.
Right.
And they'll say Stab Lock on them. Okay. But again, it's really important that, like, so you can see here, these ones are white breakers with a black handle. These are acceptable. Okay. It's only Stab Lock that is concerned, and Pushmatic, but those are pretty obvious. But Stab Lock specifically is one of the brands that lost its CSA approval and had to redesign its breakers in order to meet CSA requirements. So again, these breakers would be acceptable. The old black style Stab Lock, they'll still say Stab Lock right on them, but they're black body, black handle. Not acceptable.
Okay, thank you.
Can you hold on 1 second, guys? I'll be right back. I'm gonna go grab, I've got a Stab Lock in my car. That's not acceptable.
Any questions, guys, so far? No? Okay, awesome. So when it comes down to these I guess non-compliant pieces of equipment that we've been discussing, like the Stab Lock breakers, we're gonna probably talk about federal panel boards as well. Again, it's up to you how big of a deal you want to make it with your clients. It's always best to advise and say, hey, you know what, this component or this appliance no longer is acceptable. It was when the dwelling or when it was installed. But just so you know that, you know, it will have or may not have the proper safety ratings anymore. And like, so we're going to come up to a few more recalled electrical components here really quick. She's all yours there, Jesse.
So this is a Stab Lock breaker as well. This is a side view of the one on the left. This is the black body that I'm referring to. So you can see if I turn it, black body, okay, black handle, okay. Okay, white body, black handle, acceptable. Black body, this is not a CSA approved breaker. It was at the time it was installed, but they lost it, okay? And again, it's really tough to see on this one, but you can see it says Stab Lock right there at the top. Getting kind of tricky, okay? And then this side, we got the Federal Pioneer Electric, okay? This one, even in itself, if we look at the end of it, again, I don't know if you guys can actually see this or not. Of course, I got coffee hands here. It says CU-AL,
Yep.
copper aluminum rated. So even this one that doesn't have CSA approval anymore still is acceptable to have copper or aluminum connections. Okay. All right. Let's carry on. Where did we get to? Oh, recalled Stab Lock. Okay. There's certain brands that we need to be conscious of or time periods. that were recalled. I'm not too familiar with specifically the arc faults, but I believe it's pertaining to the red numbers on the right side. Is that correct, Alex?
Yeah, with the date range. So you'll see the 0410 to 0439. When you see those stamped on them, those have been recalled. So just kind of be aware of that. And then the image on the right, these blue test button square D breakers are also have been recalled. Again, so just kind of be mindful of the dates for the stab locks. That's the ones on the left, and you'll see where actually says stab lock right above the number date. And then of course the blue test button on the square Ds, because they may be other colors and those are not in the affected recalled span.
Stab blocks are the ones with the screws to terminate the wire into the breaker, hey?
Yeah, the ones
Yeah.
on the left hand side.
Yep, gotcha.
But
Okay,
we're all looking at the same presentation.
Yeah. So again, you can see, if you look at the picture on the left, you can see right here it says stab lock. Again, this one here on the right, that's square D, and literally always has a square with a D on it on the inside. May say Eaton, may say Siemens on it. There's a ton of different types of breakers. GE makes panels. Leviton makes panels now. So there's a lot of different types out there. For the most part, it'll be adequately labeled. So there's not a big concern with like being, oh my goodness, I'm going to run and do a panel and have no idea what it is. It'll probably take you 3, maybe 4 inspections, and you'll be like, oh, okay, this is not something I'm going to run into often. This is not like, you don't stress out about the fact that you're not going to be able to tell what type of panel it is. You will know almost immediately upon walking up. I mean, if you can't look at this right here and say, oh, there's a square and a D, and know that that's square D, you guys will be okay. Not a concern there. There's no need to stress on that. So, okay, recalled square D AFCIs. A lot of manufacturers, when they first put out their arc fault breakers, a lot of manufacturers had issues with what's called nuisance tripping, and they just trip for no reason. Okay, I'll tell you, it was the biggest pain in the butt that we had to deal with, because we put in a bunch of breakers and we got to go back for free and change them all out again. So just be conscious of, any recalls, whatever that might be. Again, I don't know if that's something that you guys are required to be conscious of, but again, it's just an added bonus as an inspector, to be able to say, you know what, I know for a fact, these are recalled breakers. So, oh dear, we skipping ahead here. Corrosion, again, excess moisture. That's really all that's going to cause that. Whether it's coming from that drip loop not done correctly outside, making its way inside. It could be previous water damage inside the home. Could be excess moisture due to that grow up that you're working at, that definitely legal grow up that you're working at. Again, just be conscious of that, because anytime you've got rust, you've got heat, okay? And heat is fire. So, okay, this is a good one because we can kind of talk about a few things here. So, one thing you might see is stray strands, okay? All these little tiny strands need to be inside that lug, okay? It's gonna cause heat, specifically maybe on these lines or just on this line. The other thing that you might notice is called, it doesn't really have a proper name, it's just an industry thing. It's called trimming or nipping a wire. Do we have a picture of that, Alex? I don't think so.
No, I don't believe so.
Okay, that's okay. So what it means is the electrician got to site, decided that this cable right here, this black cable, needed to go inside this lug, and he tried and couldn't get the cable to fit. So he's like, well, I mean, there's 10 of these little strands. I'll just cut off one of them and then the 9 will fit. But you've effectively derated that cable. So what, you know, maybe it was good to 15 amps, now it's good to only 13. So you need to be conscious of trimming or nipping. It's not okay. You've derated that cable, okay? Again, this is a great example of a stab lock. So this is another stab lock panel. You know, you've got your black body stab locks, no CSA approval. Got your white body stab locks, good to go. Your 2-pole stab lock, black body, black handle, no CSA approval. Then we're back to the red one, we're good. And then a black one, no good. So I think we covered all the stab lock stuff there. So we've kind of talked about this already. Oops, oh dear. Okay, we've kind of briefly talked about this already. At the first point of use, or the first panel in your home, the neutral cable needs a direct connection with ground. We kind of talked about this, saying we want to make sure that that neutral cable is zeroed. It's guaranteed it's going to be a 0, okay? And we use a neutral bonding jumper. We connect that neutral to the ground at the first point of use, okay? If we go out to a sub panel, you do not have a connection. So you'll see in this picture, it's showing that the neutral and the ground are directly tied together, okay? When we go off to the sub panel, there's no connection between the ground and the neutral, okay? So you can see if this was a main panel, this would be acceptable. We come in with our neutral, we tie into here, and we tie into the panel. So there's a connection between the neutral, and the ground. Looking at the picture on the right, this is the neutral bar right here and right here, and it has a green screw which literally goes right through the back of the panel, and that is your neutral bonding jumper, okay? If this was a sub panel, this would not be acceptable. That needs to come out. That green screw, that bonding strap, that bonding strap needs to come out, okay? This method on the right, or on the left, is probably not sufficient. Just take the extra 3 seconds and cut it out. On the right side, that is acceptable, okay? Rotating it, there's no chance that this is ever gonna accidentally touch this neutral bar, not a concern, okay? I would probably have my techs pull it out just as preference, and it just looks kind of crappy, but this is acceptable. There is no longer a connection between this neutral bus and this ground, or the can, or whatever, okay? Poor installations for sub panels. Again, wires required to have mechanical protection. So whether that's an armored sheath around the cable, so like literal physical armor, or a conduit, or a cable tray, whatever that might be, it needs to have mechanical protection. This is a poor installation for a multitude of reasons. Number one, this cable here, it has no insulation or no jacket, okay? This cable is not protected before it enters into the sub panel. So again, be conscious of mechanical protection for cables. This right here, coming off the right side and the left side, is technically acceptable. An inspector would let that slide. Bonding, we talked about this. Bonding is the interconnection of current carrying and non-current carrying components to ground. So water systems, gas lines, receptacles, lights, plugs, dimmers, boxes are required to have a bond. You know, things like a hot water tank needs a bond, a furnace needs a bond. Everything that has electricity to it in your home requires a bond. Okay. Some switches have a bonding terminal, so they have a green screw. You need to use it. Some don't. We use switches that don't have them. They do not use electricity, and they've got 2 screws that screw into the metal box, which bonds them. Okay. Biggest thing, water line and gas line. Make sure they have a bond. That's really the 2 biggest ones. They're really easy because they're typically in a mechanical room. And so they're very accessible to be able to bond them. Bonding. So again, you can see on the right side, we'll start there. You can see it comes up and it actually bonds with, I don't know, a water line or a gas line or whatever that actually is, that pipe, but it's got a proper bond to it. Okay. Looking on the left side, you can see we go out to a ground rods, we come into the panel, we hit the ground bus, and then we actually go out to the plug and we bond that plug. So, okay. Gas line bonding, water line bonding. Again, as long as it's bonded, so we can use other pieces of the system to make sure that it's bonded. So in this application, someone probably ran a bond to the water line near the panel, or maybe the gas line near the panel, and all they did is they ran a jumper from the water line to the gas line. That is a sufficient bond. Okay, as long as they are bonded at some point or connected to ground at some point, it's acceptable. Okay, you can see on the right side, we talked about earlier, if there's a water meter, there must be a jumper that goes over the water meter. Okay, some of the new water meters are entirely plastic, like all plastic, and you're not getting a bond from one side to the other. So it's very important that this is in place. Specialty overcurrent protection devices, arc faults and ground faults. Okay, arc faults. So you have a few different options. One of the most common options is the arc fault breaker. That's the far left. Okay, it's the easiest way to do it. What you'll find is on newer houses that get renovations, the panel might be full already, or it might be nearing being full. So electricians will often, move to the option of having an arc fault receptacle or a dead front. This is an acceptable method. Okay, arc fault breakers are very expensive and they're very difficult to get, which is a large part of the reason you'll likely see them missing from newer installations. If you notice that a basement is developed within the last 5 years and there's no arc fault breakers, it, number one, doesn't have a permit, and number two, it's not to code. Okay, arc faults detect an arc between the hot and the neutral. Okay, ground faults are ground and hot. Okay, arc fault locations, these are the exemptions. So these are the only circuits, according to current code, that you do not require. Do they have this in their modules, Alex?
Yeah, you betcha.
Perfect. Okay. So these are really important to note. So bathroom, washrooms, receptacles, anything near a sink does not require arc fault. Fridge does not require an arc fault. A gas appliance does not require an arc fault. Kitchen counters, so that's peninsula, island, pretty much anything in a kitchen counter, and a sump. Okay. The only reason a sump can be exempt is if it's just a single receptacle. So the only thing you can plug into it is a sump, and it must be labeled sump only. in order for it to meet that code requirement. Okay. Lights do not require arc fault protection. Okay. And what else does not require? Any hardwired electrical devices do not require arc fault protection. Okay. So that would be things like a furnace, which is not a plug-in furnace. So if it's just directly wired right into the furnace, it doesn't require arc fault protection. What else would be hardwired? Maybe like a fireplace, an electric fireplace could be hardwired in the back, does not require arc fault protection. Okay. So yeah, that's pretty much it. GFI options, again, exact same. You could do dead front, you could do breaker, you could do receptacle. Okay. In this application, receptacles are the most common. Okay. And a good rule of thumb is, again, if you can stick your hand in the sink, right in the sink, and you can touch the receptacle, it requires arc fault protection. Okay.
I think Jesse meant.
Or sorry, thank you. GFI protection. Okay. The distance is 1.5 meters from a kitchen sink, a bathroom sink, any sort of pool that has running water to it. So a hot tub, air tub, jet tub, whatever that might be, will require GFI protection. A lot of times they'll hide them underneath in the access panels, just so nothing else gets plugged into it. And then any exterior receptacles require GFI protection. A soffit plug, so one that's installed face down underneath a soffit, is exempt from that rule. Soffit plugs do not require GFI protection. Not particularly something that you guys need to be aware of, but the way a GFI is wired, or an arc fault is wired, is the actual breaker itself has two connections. It has a neutral connection and a power connection, and then this cable actually ties onto the neutral bus. Okay. Arc faults are wired the same way, and this allows it to monitor leakage current. Okay. If it's not wired correctly, it won't function. So, I mean, if you're not getting it to trip with your plug tester, it's likely that it's just wired incorrectly. Okay. Receptacle wiring. Okay, manufacturer spec will indicate how many plugs afterwards you can GFI protect with that GFI. I believe most are either 2 or 3 afterwards. But again, you'll have a line side and a load side of a GFI. Okay, from the panel, you go to the line side, and then anything you tie onto the load side of that GFI is going to be GFI protected. Okay. Distribution, let's see. I'm going to take a quick 5-minute break. And we'll come back at 11:23. And then we'll do 45 minutes.
Do you want to do just 25 past?
Sure. Sure.
Okay.
Yeah.
Okay.
Distribution. Okay. Okay, so talking about conduits, we kind of briefly touched on where they're required. Again, this is, I mean, for the most part, you're going to need to know that services require rigid steel or PVC conduits. If we're talking metal or metallic conduits, anytime you extend past the roof line, you're required to have rigid steel conduit. If you're using just interior conduit for plugs or lights or anything like that, you're going to be using EMT unless it's in an explosion-proof atmosphere, which again is not very common when you're doing inspections. Bare flex or flex is flexible conduit that's used for connecting motors. Interior though, liquid type flex is just a flexible jacketed cable that has a rubber coating around the outside. You'll see it quite often in AC connections. Is really common. Motors that are in damp areas. Again, more on the commercial side of things rather than the residential. With rigid conduit, you're going to have threaded ends. So you'll see stuff like this, and the conduit literally twists in. So, I mean, you'll see a bunch of different types of conduit. This is actually EMT conduit, so thin wall conduit with rain tight fittings. Okay, if this didn't surpass the roof line, EMT would be acceptable. If it went past the roof line, it would be required to be rigid steel conduit. Rigid PVC conduit is more common on underground installations. So whether it's the service coming in or a subservice or out to a garage, those types of things. PVC is a rigid conduit, and anytime you have conduits that are subjected to mechanical damage, so whether it's vehicle or impact of some sort, a forklift or anything like that, it's required to be rigid conduit. Conductors, you're going to see multiple different types of conductors. You're going to see 2-wire, 3-wire, 4-wire. You're going to see stranded conductors. You're going to see solid conductors. So the ones on the right here, these are solid conductors. The ones on the left are stranded. For the most part, the only stranded conductors you'll see are going to be things like the ground cable, the cable feeding the range, the service conductors, the cable feeding the dryer. But for the majority of the wiring inside of a home is going to be solid conductors, which are the ones on the right here. So again, on the left here, you can see this is an aluminum cable, and it is a stranded conductor or a multi-strand conductor. Alex, can you speak to AA8000 and AA1350? Because I think there's some particulars about the two different types of aluminum that I believe you know a little bit more actually than I do.
Yeah, no worries at all. So this is going back to what we were discussing initially about the aluminum wiring back in the late 60s to the early 70s, and that's where we have all these issues now where there's arcing, there's fires and whatnot, and then we'll be talking about some rectifying methods here pretty quick. But with that conductor, that is actually the AA1350. So that's the single strand conductor that we're having issues with now, that was installed decades ago. Now this aluminum conductor is actually a different type of material than the typical AA8000. So the AA8000 is generally your service feed. So it's multi-stranded. It's more resistant, I should say, sorry, to the cold flow, the expansion and contraction, which would loosen up the connection points. So the big thing is, when you guys see the single strand aluminum conductors, that is absolutely required to have the anti-oxidizing paste. It's also, most manufacturers, and basically you'll see the anti-oxidizing paste for the AA8000. Again, you may see the multi-strand going to a dryer or a range in your installs. And again, if you see the anti-oxidizing component, that's great. If you don't, you may still recommend that the homeowner or whoever installed it further look with the installation manual of the manufacturer. If it is required, chances are it is. But that's the big difference between the two conductors, where the AA1350 is the original Vietnam War, late 60s, early 70s material versus the AA8000, which is what we use today for the bigger appliances and the service.
Yeah, and I mean, if an electrical inspector doesn't see anti-oxidizing paste on aluminum conductors, they'll make you put it on. Regardless of whether it's AA8000 or 1350. So, I mean, that just, I think, has become kind of a status quo and an expectation in terms of the use of aluminum cable. So, so again, talking about aluminum cable in and of itself is not unsafe. Okay, the connections are what make it unsafe. So you can see on the right, this is literally what happens when you're using aluminum cables. Over time, they expand and contract until you end up with arcing, and then you end up with heat and melted or burnt or exploded conductors. On the left here, it's a great example. That blue Moret is probably the most common Moret in all of North America. It is Moret brand Morets. They are only suitable for copper to copper connections. Okay, if you are doing a copper to aluminum connection, you are required to have a Moret that is rated for copper to aluminum connections. Okay, some of them are brown, some of them are purple. If a Moret is brown or purple, it is aluminum to copper rated. So aluminum to copper rated Moret is brown or purple. No other color. Brown or purple. Okay. The only way you can, quote, fix aluminum while it stays in the walls is to splice on a small section of copper onto the end of every piece of aluminum and replace any aluminum to aluminum connections with aluminum rated Morets, so brown or purple Morets.
So that's basically the cheat way, Jesse, to replace aluminum then, is just do what you said there, hey, rather than ripping out all the wiring throughout the house.
Correct. Yeah, and it is a totally accepted method. You referred to it as a cheat way, but honestly, it's the way. It's the way. Without rewiring. Yeah, it's. I mean, and it's pretty obvious. You can, for the most part, as soon as you open up a panel, you'll see it almost immediately that there's been. You're absolutely right, Wes. It is called pigtailing. Yeah. So it's referred to as pigtailing. And that is the method for rectifying it. It's kind of an odd one because you're not technically doing any work. You're not adding or removing from a system. Some municipalities don't require a permit, some do. So it may be a situation where you have to pull off a cover plate on a plug and shine a light inside the plug to see if the aluminum's been repaired. The second you see aluminum in a panel, I would recommend you pick a random plug, maybe 2 or 3 throughout the house, and see if they have purple or brown Morets inside to determine whether or not it's been adequately fixed.
So can you tell if there is that anti-oxidizing paste on there, Jesse?
Yeah, it looks like gray goop. You'll see it in the panel because the panel is required to have it on the connections as well. Now, without removing a Moret, you won't see it, but a lot of the purple Morets come preloaded with it. The brown ones do not. So, I mean, it makes a big mess. So for the most part, you should see some evidence of it somewhere. But if they've taken the steps to put brown Morets on, they've likely, taken the steps to put anti-ox on there as well. It's a good thing to note in your reports. Aluminum wiring was noticed. However, the presence of, aluminum, copper, Morets were noted. Appears to, have a proper repair, confirm with electrical contractor or electrician to determine extent of repairs or something like that. I mean, it's good to note anyways, but it is technically met the requirements of code in terms of a repair if it's got those purple or brown morettes.
If it didn't, I mean, it's probably not that hard to get an electrician to come in and quickly put the proper morettes or the paste or whatever, right? Just in case the client or customer was concerned, right?
Yeah, and I mean, to be honest, if it's just an aluminum house and it's not been changed or not been pigtailed, you're probably like $3,000 or $4,000. A standard blue moret is about, I want to say probably about two cents, 2 cents, maybe a penny for a moret.
Yeah,
And then an aluminum rated moret is I don't know, $1.50. So there's a huge price difference between the two. So just, I mean, obviously you want to point it out to your clients, but it is not a small expense if it has not been done.
Yeah, the reason why I ask is because, like, you know, if it's something very little, you don't necessarily want to get or talk the client out of the home, right? So I mean, if it's like an easy fix, it's nice to know, like, hey, you just mentioned, hey, it's not that big of a deal. It can be easily replaced or fixed. So
yeah.
I'll make a couple notes. So, you know, this is when you come across aluminum wiring. So again, tail end in the Vietnam War, late 60s, early mid 70s, possibly, depending on your jurisdiction. This is the same kind of stuff that you want to point out in your report if you come across Poly B, Kitech, or Vermiculite, right? So this is one of those big red flags for insurance companies. So if you don't point it out, you know, you may be getting a call from your client later on down the road. And you know, another reason why pigtailing is preferred is because typically in that area of a house when aluminum was used, there's a good chance we got asbestos in the walls, in the drywall, mud compound. So, you know, if you start ripping out the walls, now you're opening a whole new can of worms, which Jesse, I mean, I'm sure he's very well versed because of his remediation company. So.
Yeah, absolutely. And I mean, it's when you're dealing with a house that was built from 1960 to like 1980, it's going to have just a real handful of delightful little treasures for you to find. You know, you're going to run into Poly B, you're going to run into aluminum wiring, you're going to run into asbestos, you're going to run into, I'm sure there's probably a few other things that I'm not even aware of at this point. Lead paint on the exteriors. I mean, it's 1960 to 1980. Just be really diligent in you know, in your inspections, because you're going to run into a lot of different things. And I mean, Alex is absolutely right. I mean, as soon as you you know, see Poly B or I believe there was a type of PEX at some point that was an issue. Not too familiar with that, but aluminum wiring, all these different things, there's a good chance that, you know, simply removing it and replacing it is not an option, because you end up in a situation where you have to then do a remediation, which could be $25,000. So again, they tend to spiral, and pigtailing really is probably fiscally the best option, and even that is still relatively expensive. So okay, purple morettes, these are the best to fix the problem. Okay, you can see they're preloaded with a little bit of antiox in there. They tend to have like a almost like a shutter, like an X shutter inside, and if you were to stick your finger in it or a pencil or something like that, you'd actually pull it out and you'd have a little bit of antiox on your fingers. Okay, the one on the right is another acceptable method. I'm not a huge fan of the ones on the left, but they are acceptable. They're typically more expensive, but again, still an option. I think you guys have this in your modules, but if you don't, take a picture. This is really important. Okay, this is copper. Okay, this is important. Aluminum is, for the most part, one size larger than copper. Okay, so number 3, copper, is good for 100 amps. Okay, number 2, aluminum, which is one size larger, is good for 100 amps. Okay, we typically use copper up until number 6, and then we switch to aluminum just from a cost perspective. Okay, you're finding with a lot of shortages, you're going to see number 8 and number 6 are aluminum or is being switched to aluminum. So you'll end up with number 4 aluminum or number 6 for a range or stove. Okay, so this again is a really helpful guide of what you should expect to see. We talked about mechanical protection. This is a great example of mechanical protection. So on the left here, none at all. Okay, this is not acceptable. It doesn't meet the requirements of code. It's an easy one. Snap a picture of it. No mechanical protection. Okay, on the right side, they got halfway there. We've run AC90 or BX, or armored cable, for the last couple feet, which is acceptable. But then on the feed to the disconnect, we've got NMD. So again, maybe you're putting pots and pans in here, or maybe you've got some garbage cans. That is not mechanically protected. You can squish this wire a little bit, this armored cable, you can pinch it, and it's going to be a lot more difficult to pinch or break or anything like that. NMD or NMS is going to be really easy to pinch or cut or break, so it needs to be mechanically protected. Again, really great example of NMD non-protected. On the left there, going to the hot water tank, needs to be secured. So it can be even secured to the edge of the gas line, just tie wrap to the gas line and then pop off in the last minute, last foot. Stove is the same thing, needs to be armored cable. General rule of thumb is if it comes down the furnace, it needs to be armored cable down the side of the furnace. And then once you get up and into the joist spaces, you can go back to NMD or NMS, to Lumex cable, because it's protected by the joist spaces. Couple options to protect. P plates or protective plates. It can be a pre-manufactured plate, whether it's screwed on. Some of them just have these like prongs, and you take your hammer and you just whack it in. You pretty much can expect to use these anytime that the holes are not in the center of the stud or in a kitchen, because cabinet makers like to use these nice big long 3-inch screws to get their cabinets to stay up. Okay. Heat ducts. We want to make sure that there's a separation between the heat ducts and the cables. If it's a cold air return, we want to make sure that it's not really relevant for keeping that separation. But yeah, big thing is heat ducts. Can you guys just hold on 1 second? Sorry.
Yeah, so with heat ducts, guys, this is a more recent code requirement. So you are required to have 1-inch clearance between heat ducts. So again, when you're inspecting older homes, I believe it was 2019 when this came out. But when you're inspecting older homes, it's not a requirement. By all means, you can let your clients know that, nowadays we have a different standard for the proximity of heating ducts and circuit conductors. But if you're doing an inspection of a brand new house or again a basement development and you see this, that should cause you to question whether this was permitted or who did the installation.
Yeah, and a simple fix. Yeah, simple fix is just putting insulation in between the heat duct and the cabling. Yeah, sorry about that, guys. I just had somebody talking in my office and it was making things a little hard to concentrate. So had to lay down the law. Incorrect use. NMD is not rated for temporary installations. It is rated for permanent installations. So someone has put an outlet on here, strapped a piece of NMD in here, and called it good. That's not acceptable. You have to use cables like SJOW or SOW that are meant for temporary installs. So the cable that is an extension cord, that's SJOW. If you do have a code book, you can look in the back and it shows you all the different types of use for different types of cable. So say NMD is good for dry applications and must be mechanically protected, and only permanent installs. They'll say things like AC90 is good for surface. That's BX or armored cable. It's good for surface installations and provides mechanical protection, but again, only for permanent installs. So they talk about the different applications for different types of cables. So on the right, we've got open splices. This is never ever been acceptable. It's never been an acceptable practice. Every splice, every junction must be in a box. So snap a picture of it, put it in your report, open splice, code infraction. There's no need to reference a code for that. That's a pretty hard set rule, never been acceptable. So doesn't matter how much tape you wrap around it. Combustible clearances, again, very similar to the heat ducts. Whenever you've got excess heat being produced, you want to have separation. So honestly, the easiest thing is just to slide a piece of insulation in there. That's not on you guys to do, but it's something you can advise the homeowner that they can do themselves. That's a really simple one. Exterior use. NMD or NMS or Lumex, this cable right here, is rated for dry use only. Okay, it's not rated to be buried. It's not rated to be in a wet location. It has, let's call it a sister cable. It's called NMWU. Has a black jacket. It's rated to be directly buried. Okay. That is in this application what you would use, and then you would mechanically protect the cable. Okay. You can't use armored cable in this application because armored cable is only rated to be in a dry application. Okay, it just corrodes over time. Again, common defects, extension cord splice. You're going to see some really creative things when you guys start inspecting homes. Again, just not acceptable. Extension cords are temporary use only, and again, can't be used in this application. Okay, yeah, that's impressive. On the right, you've got NMD being used as an extension cord, so we've got the opposite. Again, NMD or NMS is only for permanent installs. Okay, can't use it as an extension cord. Missing a bushing, that's a steel stud. Anytime you go through a steel stud, you either have to install a bushing around the opening, or you can use armored cable. Okay. It just needs to be mechanically protected. Over time, it'll vibrate or move, and there's a potential for this cable to become damaged. Okay, live abandoned wires. Obviously, it needs to be in a box or needs to be disconnected and terminated so it can never be used. That's just simply a hazard. Again, these are the kind of things you're going to run into. Just note it, live wires or live abandoned wires. You're going to refer to electricians quite often, and they'll put together, whatever's needed to rectify the situation. But again, we talk about mechanically protecting cables. For the most part, this is an acceptable method throughout all of Canada, not just Ontario. This is a safety bulletin. Again, safety bulletins every province has different safety bulletins. We all deal with different things. You go to the West Coast, specifically, you're going to deal with, earthquake protection. We've never had an earthquake in Alberta that I'm aware of, at least, or one that's really been relevant to a point where they engineer or have codes or safety bulletins relative to earthquakes. But again, providing mechanical protection, it can be tight to a running board. It can be in areas lower than a meter. It can be along joists. For the most part, this is one where unless it's really, really obviously not protected, so it runs across several boards or it's laid on top of the insulation, or it's strung out somewhere, it would be classified as mechanically protected. Okay, so here's another great example showing the basement ceiling protection. So you can see these are acceptable as soon as you move, into an open area where there's where there's no protection. You run into issues. Again, you've got a bit of mechanical protection here with the support posts and against the ducts. But you also want to be conscious of the fact that is this a cold air return or is this a heat duct? If it's a heat duct, maybe we can't run it here. Is this in the mechanical room or is this in the general basement area? If it's in the living room basement, this would likely not be acceptable. So just being conscious of that is important. Okay, so you can see on the right here, this is actually a great example. So if this was a crawl space, I would argue that this is mechanically protected. This would be considered like a mechanical area. If this was a basement, where this was a full height ceiling, I would suggest that maybe this would need further mechanical protection, whether it goes through the joists or it gets run, along the joists and then down and on the ends. There's a few ways you could rectify this. Installing a drop ceiling is one way. So anything run above a drop ceiling is mechanically protected. Open junction boxes, again, this is something that you're going to run into often in an attic or a mechanical room. I don't know why you don't take the extra 2 minutes to put a cover on it, but again, every junction box needs a cover. It's a simple fact. So conductor use, NMD or Lumex or NMB is dry and damp locations, not wet locations. Okay. NMW 90 is dry locations only. Okay. It's not very common. NMWU, this is direct burial. Okay, so let's call it the sister conductor. That's good for direct burial, has a black coating to it. AC90 or BX or armored cable has an aluminum armor around the outside or a steel armor around the outside. And it's good for dry locations and surfaces. So you can run it along a surface and it meets the requirements of being mechanically protected. So again, NMWU, you can see the black sheath on it. That gives it its, additional moisture protection and direct burial protection, just a thicker insulation. Okay, this is AC90 or BX or armored cable. Okay, when you cut this and install it into a box, this lip right here is quite sharp, okay, and will cause shorting unless you put an anti-short in it. Okay, when this is installed into a connector, you can clearly see the anti-short. It's red, always bright red, always red. And you can look into the connector, there's a little hole and you can actually see that an anti-short's been installed. Conductor location and use, AC90 below grade, not acceptable. It is not rated to be damp or moist or direct buried. Okay, so this would be a code infraction. Okay. Tech cables and ACWU. Tech cable is a armored cable that has a rubber jacket around it. Okay, ACWU, same thing. I think these are actually swapped. I think this is ACWU on this side. It's aluminum tech, and tech cable is copper tech. So we talked about this a little bit earlier. Knob and tube wiring. It's very old. Okay. It is, again, it was acceptable when it was installed. And therefore it is technically okay. Most inspectors, when they see it, will call it on it being a safety concern and tell you need to remove it immediately. The best way to explain knob and tube, other than visually seeing these open conductors, they're just single conductor wires. And a lot of times they've become bare over time. So you'll literally see bare live conductors running through a house. And that's, for the most part, what the safety concern is. It'll be, this is probably what, 20s, Alex? 1920s, maybe even earlier, 1910?
Yeah, around then, I think 20s.
Yeah, so you won't run into knob and tube very often. Okay, a lot of times it's abandoned in older homes, but for the most part, you're not going to run into it too often.
Quick note with knob and tube, guys, so that's where your voltic becomes really, I guess, imperative to have in your tool bag. Like Jesse said, a lot of times it will be abandoned, which is great, but if it's live, the insurance provider will likely request that it be removed. So again, just an additional cost to your clients, the buyers of the house, if you have live knob and tube wiring. And the way you can tell is obviously you can see the knobs, which are the little porcelain, cylinder-like objects with either a nail or a screw through them. And then the tubes is just basically looks like actually I have one here. Hold on. This is what a tube looks like. I'm just gonna pull up my full screen. So this is what a tube looks like. So just basically provides a channel for the conductor. So now, Jesse, did you want to take that break now? It's 12 o'clock.
Yeah, let's do that, and then we'll reconnect at 1 o'clock.
If you have any questions, guys, by all means, you can put them in the chat or save them until after lunch. And this is going to be a bit of a longer break, so it's 1 hour.
Yeah. So I'll catch you guys after lunch.
Awesome. Sounds good, man.
All right, guys, welcome back. Jesse is going to be joining us here in a couple of minutes. Any questions so far about anything that we've discussed? Is it all making sense? Any topics that need some further clarification? Oh, okay, awesome. So just to recap where we left off, guys, basically, again, when you see this knob and tube wiring, typically it's going to be in homes built before the 50s. So a lot of times it is inactive, but at the same time, that's why you want to carry around your voltic, just to make sure if it is active that you point out to your clients, let them know again that there's a good chance that the insurance provider is going to request that they have it removed. And as you can see, it is called open wiring in the Canadian Electrical Code. So it is still allowed to be used if done properly. However, the big implication with knob and tube wiring or open wiring is that it is required to be in an open space. And generally where we see a lot of the infractions with this material is up in the attic spaces. So I believe we may or may not have some images here, but in the building science presentation, if you guys recall, you saw a few images that had a bunch of insulation covered on top of the open wiring, the knob and tube wiring. So again, because it can overheat, you're not supposed to have anything around it. And And then just go to the ungrounded receptacles, the image on the right. So this is what Jesse was talking about when you see only the two prongs. Grounded bonded receptacles, when they're wired properly, they'll have that middle lower pin, which is for the bonding pin for anything that you plug inside of it. And again, typically with ungrounded receptacles, those were found pre-60s. So whenever you inspect these older dwellings, pre-60s, especially from an electrical standpoint, just be aware that you're probably going to come across marginal service feeds. So anything less than 100 amps is typically defined as marginal service. You're probably also going to find ungrounded receptacles. You may or may not come across live knob and tube wiring. And chances are, if it's the original installation, you're going to see a few other items such as, no GFIs, no AFCIs. You may not even find any receptacles outside, as is pretty common, pre-60s. And obviously, your outlet analyzers, they will not be able to test the ungrounded receptacles, so you can just simply disclose in your report that you're unable to test them just because your outlet analyzer doesn't allow you to do so. Any questions about that, guys? All makes sense?
Yeah, you betcha.
Okay, just making sure we got people here still. So
Yeah, you're not talking to yourself, Alex. It's all good, man.
yeah, wouldn't be the first time. So
Sure won't be the last. Yeah.
no doubt, no doubt. Okay, so I'm just going to steal Jesse's thunder here, and we're gonna just take off. Like I said, I think he's just kind of parking his vehicle. He had a meeting that just took a little bit longer than expected. So yeah, you betcha. So
right.
you guys can all see this screen here that I'm showing, the 15 amp receptacles.
You betcha.
Okay, awesome. So typically when wired properly, you guys will see the common duplex receptacle. That's when you have the receptacle top and bottom. And again, this is generally on 120 volts. My apologies. So that's just your first phase. Yeah. So typically when your outlet analyzer reads a correct reading, this is your neutral side. This is your hot side, and then this is your bonding pin or bonding screw, if you will. So oftentimes you're going to see a lot of miswired situations. So a reverse polarity, which is really, really common, and it's a pretty clear indication it was either an apprentice or a DIY installation, is where you have the hot wire installed where the neutral should be, and the neutral installed where the hot should be. Again, a lot of times you're going to see ungrounded receptacles, which is basically where they don't have the bonding conductor tied in. So, and by no means are you guys required to remove any receptacles and do any sort of testing. I generally would not recommend that you do that. If you want to do with the cover plates, it's up to you. But again, if you cause damage to the cover plate, the face plate, or say you push it in too far, and then who knows, you may get an arc, down the road once you leave, you may be held liable. So it's generally good practice not to remove any sort of covers off, unless it's a junction box where you feel it could be safe. Because a lot of times you might see in older homes where they have renovations where you might see different materials where you may question that you may have aluminum wiring inside of it. So at that point, by all means, if you want to open up the junction box cover or the faceplate of the receptacle, you can, just to see what's going on behind it. So you may have.
And sorry.
Oh, hey Jesse.
I'm gonna interject. Yeah, sorry, I've been sitting here a while. Sorry guys. And everything you need to know is going to be, told to you by this little number right here. Reverse polarity, open ground, open neutral, open hot, whatever that is. It'll all be here. And realistically, you should never have to pull a plug cover off. If you do pull a plug cover off, share my screen. If you ever do pull a plug cover off, just be conscious of the fact that if it's plastic, when you go to put the screw back in, plastic plates will crack. Thermoplastic ones you can actually take and you can physically bend the plate, and it will keep its shape. I would encourage you just to go to even Home Depot and even just walk down the aisle, grab one of the thermoplastic ones, grab a plastic one, and just feel the difference. And you'll know right away. You'll be able to feel the difference between the two. And just like Alex said, if you go to twist a screw back on for a plastic plate, and you even a quarter overturn, it'll crack. Tamper resistant receptacles. This is a new code or newer code. I want to say 2012 or 2015 would have been when it came into enforcement. All it is you could take a key and you could effectively stick a key in one of these slots here. And unless you're sticking two keys in at the same time, like on your plug tester, unless you're sticking them both in at the same time, those shutters are actually not going to open. Again, this is, due to the fact that people were sticking things in receptacles. So this safety feature came out. It's pretty easy to tell because you can see the actual shutters inside. And then in addition to that, a lot of them will actually say TR for tamper resistant. So
it actually only allows a plug-in to go in there rather than keys or a knife or a fork or whatever some young kid may find.
Yeah, you betcha. And I mean, again, as long as it's manufactured by a reputable manufacturer, I am confident enough that I would stick a key in one side and not be concerned about getting shocked. So they are a good. The theory behind them is actually really good. It is a great safety device. So I mean that's.
Are most of them TR now with new homes and whatnot?
It's a requirement that they're TR.
It is a new requirement now?
It is an electrical code, yeah. So if you see a house, I would say I'd have to actually confirm this by looking at my code book, but an older code book, but I believe it's 2012 and newer require TR receptacles.
Gotcha.
I think there's a few exceptions, Jesse, of course, correct me if I'm wrong, but receptacles above 2 meters not required. And if it's a dedicated receptacle like a fridge or a microwave or a washing machine, then it wouldn't be required. I mean, this is mostly for kids,
Yeah, and I mean, again, the code, the way that I understand it is if it's, I think you're right on the 2 meters. But again, just to give you an idea, a tamper resistant receptacle cost me about $1.65-ish, give or take, $2, somewhere around there. Non-TR, so an old style receptacle, cost me like $2.50. So you'd have to really try to make it a non-TR, and I would be baffled if an electrician took the time to put in a non-TR receptacle. So general rule of thumb is if it's non-TR, it's not to code.
Even if it was cause for concern, Jesse, like you said, they're cheap enough where you could switch them all out anyway, and it'd be still like, relatively.
Yeah, I mean, again, it's one of those things where it's, I guess for the most part, electricians are expensive. I mean, a plug might cost me $1.60 or $2, but I'm going to charge $4 for a plug. And when you're looking at, 50 plugs in a home, that adds up pretty quick.
Yeah.
And then, you've got an electrician for a day to swap all the plugs. So, I mean, then you're $1,500 or $2,000 just in swapping plugs. So again, it's not a huge expense, but again, the expense is there. And it is a code infraction if it's not, if they're on a newer house. So typically that's something where a homeowner's gone to Home Depot and purchased some new plugs and finished their basement with them, and doesn't realize that it has to be tamper resistant.
So we would just note it in the inside, I guess more for Alex, but we would just note it in our inspection. And then if it is cause for concern or whatever from the home buyer, then they can kind of do what they wish as far as that goes, hey? Or is it up to them to?
Yeah, absolutely. And that's what I mean. The more knowledge you guys have, whether it's going back to these training sessions or learning more on I guess after your training, which is continuous education, right? We're all going to keep learning because we're going to see things that we're not presenting here. There's going to be more things that maybe in other jurisdictions. But yeah, the more you can inform your clients about potential defects, the more liability you take off yourself, right? Because let's just pretend you went to a brand new house that's never been lived in, and you forgot to know that there were missing TR receptacles, especially in the bedrooms or AFCIs, and the place burns down or a child gets hurt, right? There's a possibility you may be held liable for whatever reason, right? Our clauses, our contracts are not bulletproof. So again, it's best for you to let them know, like, hey, there are some safety features that are missing, recommend to upgrade it, and then it's on them if they want to do it.
It's all, yeah, that's just, so yeah, it is on them at the end.
It's a little disheartening, guys. I'm not gonna lie. You know, we spent hours and hours creating, doing these inspections, creating the reports, and then nothing gets done. But hey, at least you're covered down the road.
For sure. Okay, so blades of a plug, if they go up and down just like this, they're both vertical, that is a 15 amp receptacle. Okay, if they have a T, that tells you it's a 20 amp receptacle. Okay, typically the only place you're going to find 20 amp receptacles is on a kitchen counter. Again, you'll see a GFI protection for the most part on a kitchen counter. And older kitchens are going to be done via split receptacles, which we'll talk about in a second. But newer code dictates that it must be GFI protected near a sink. And the easiest way to do that is to install a T-slot, okay? Or a 20 amp receptacle, okay? Split receptacles, not particularly something that you need to be conscious of, other than the fact that in older homes where there's no GFI protection near the sink, there is likely going to be a split receptacle, okay? If this is wired incorrectly, it blows up, and it blows up big. It'll typically it'll trip the main breaker of a house. We get probably one call a year where someone's like, the power went off in my house and I can't figure out why. I'm like, did you change your counter receptacles? No. And then we go to the house and we go to reset the breaker and it blows up again, and we discover they've changed out their counter receptacles. So I guess just being conscious of how it works. The neutral side, or the white side, has this little bridge in here, which creates this as one common point. And then the other side has it broken. So you actually break that little piece, and one top of the receptacle becomes a circuit and the bottom becomes a circuit. All this does is it gives you extra power to be utilized on the kitchen counter. It's really the benefit of it, and the reason that it was put in place for kitchens, because you're I don't know, Gary, maybe you're making bread or I don't know, muffins or something, and you need that extra power for your KitchenAid blender and your I don't know, your bread maker. So by plugging into the top and the bottom, you're actually tapping into two independent circuits and getting that extra power. So kitchen counters, again, should be GFI'd. For the most part, I couldn't tell you what the distance is between the sink in this picture and the actual receptacle. But again, good rule of thumb, stick your hand in the sink, on the edge of the sink. If you can touch the receptacle with your other hand, needs to be GFI protected. It is 1.5 meters. But again, that's kind of the easiest way to do it without actually pulling out a measuring tape. Okay. If you've got switches near the sink that are utilizing a carburetor or anything like that, any usable devices near the sink, they have to be GFI protected. Okay. Excuse me. Kitchen receptacles location. Again, this is really not something that we need to spend an absorbent amount of time discussing. It's more, oh, we got something in the chat here. Is kitchen island not GFI protected a defect? It would be a code infraction, John. So you would note, again, sorry, let me rephrase that. If it is within 1.5 meters of the sink, it is a code infraction.
If it is not GFI protected, but if this distance from the edge of the sink to this plug right here is say 1.7 meters, this does not require GFI protection, okay? If this distance from here to here is 1 meter, this is required to have GFI protection, okay? 1.5 meters requires GFI protection, okay? So again, I hope that answers your question. Yeah, okay, perfect. Again, just receptacle locations when they're required. This is, again, not something that you specifically need to know. On a newer house, this would be relevant. On older houses, the code was very different. And you're likely going to see in a situation like this, you're going to see maybe 2 or 3 receptacles in the whole kitchen. Again, it was just not as common. We didn't have as many nice things. Kitchens were smaller. Mama was maybe making bread in the oven rather than a fancy bread maker, whatever that might be. So again, these distances are good to note for newer installations, but are not particularly relevant in every installation or that you inspect. Okay. Receptacle locations. So the code writes it in meters. Most electricians deal in feet. It's 1.8 meters, 3.6. We use 6 feet and 12 feet. So, within the first usable wall space. So if you've got a door that swings open, I think we've got a drawing on this. No. When a door swings open, okay, and hits the wall, the space behind the door is not considered usable wall space, okay? When a closet doors open and touch the walls, that space behind the closet doors is not considered usable wall space, okay? So when you walk into a bedroom and you open the door, it hits the wall, the measurement starts at the edge of that door. So you go 1.8 meters and you are required to have a receptacle within that first 1.8 meters. And then subsequently every 3.6. So every 6 feet to start, and then every 12 feet after. Now, keeping in mind that it works both ways, okay? So you have to go 6 feet coming from the other direction, and you have to go 6 feet coming from this direction, okay? So you might end up in a situation where you're just short. So maybe you have 13 feet of usable wall space. You're required to go 6 feet one way, and you're required to go 6 feet the other way, and you have to have no more than 12 feet in between. You might have to space your receptacles accordingly. So just being conscious of those max 12 feet and minimum 6 feet to begin with, max 6 feet to begin with, is important for plug spacing. GFI requirements, if it's outside of a home, if it's in excess of 2.5 meters, so again, I talk about soffit plug, it's kind of the few, it's really the only exception that's common. Near a bathroom sink, kitchen sink, and then things like steam rooms, hot tubs, jet tubs, whirlpools. And again, honestly, the easiest way to remember it is if you can stick your hand in the sink, touch the receptacle, it needs GFI protection, okay? AFCI requirements. For what it's worth, yeah.
Jesse, on those GFIs in the kitchen,
yes.
like the plug, would that plug have the GFI right on it, or could it be located someplace else?
It can be either or. So you have 2 options. The easiest, just slam that sucker in there.
Right.
Hit the test button. If the lights turn off, it's GFI protected.
Okay. Yeah, I'm just looking at my kitchen right now and I have 3 that I could be washing dishes and plugging stuff in, so.
Yeah.
it's good.
Are
Good to-
they a T slot? So are they shaped like this?
No, they're not.
Okay. So that means, and how old's your house?
I would say 96.
Yeah. So that means they're a split receptacle.
So that means they need a GFI then?
Nope.
Or, no, okay, so they are
Nope.
split receptacle, okay, okay.
Yeah. So if you were to put your plug tester in there,
Yeah,
and put the plug tester in the top, it would be one circuit. And if you were to put them in the bottom, it would be another circuit. So if you were to actually go down to your panel in your house and look at your panel, what you would see is you'd actually see a 2-pole breaker.
Yeah.
So it shares, it's got the A phase and it's got the B phase. It would have a 2-pole breaker, and it'll be labeled kitchen receptacle or kitchen outlets or kitchen receptacles.
okay,
And the A phase feeds this part and the B phase feeds this part. And it shares that neutral on the other side.
okay, so those ones are acceptable then?
They are acceptable. Yeah.
Okay.
You can note in your report saying,
Yeah,
kitchen counter receptacles are non-GFI protected as per current code, but it met the code requirements when it was installed.
okay, thank you, Jesse.
Okay. Same thing with like on a lot of older houses, you'll see razor plugs, big steel plate. It'll have the 2 little prongs and there's no ground. Razor plugs were designed very similar. It was like the first let's call it safety or
Acceptable.
first protection device that they came up with. And all a razor plug is an outlet that limits the amount of power that can be put out. So if you're shaving your face in the bathroom and you've literally got your razor plugged in, you drop it in the sink or whatever that looks like. The principle behind a razor plug was it's only going to give you enough current. It's not going to kill you. It's not going to trip. It's not going to turn off. It's not going to put out enough juice to actually, kill you. It's still going to shock you. It's probably still going to hurt like heck, but it's limiting that current that it can actually pass through. So it's very, from a safety perspective, it's not a GFI, but it is a limiting receptacle that limits the amount of power that it can output. So different types, but again, it was acceptable according to the time that it was installed. It is no longer an acceptable practice.
Okay.
So it is not a code infraction for the reason that it was acceptable at one point, right? I mean, there's a multitude of different codes that, at one point we thought, well, this is a great idea. Let's do this. And now they realize that, oh no, hold on a minute, this is not okay. But we accept them because they did, like, otherwise we'd be rebuilding houses every 3 years, we'd be rebuilding houses to meet new codes, right? So there has to be a level of acceptability on what's been installed before today. So
Thank you.
Well, I'll make a quick note. For those split receptacle guys, and again, this is typically older installations. Your breaker panel, like Jesse was saying, you have the 2-pole breakers for the kitchen receptacles, and they're generally labeled if it was done professionally. And those are going to be 15 amps, right? So you'll see 15 on it. So again, if you start inspecting older homes, that's what you're going to see.
Yep. Acceptable receptacles on the floor. I don't think we've talked about this, but require floor covers. You cannot just put a standard plug with a standard cover on the floor. It's not an acceptable method. Okay, it has to be rated for its use. You'll find a lot of electrical things are actually really, really simple if you think about how they were designed. A standard light switch was designed to be on the wall. That's rated for its use. A certain type of cable was designed for specific use. A certain receptacle was designed for specific use, whether that's to be put into a wall or to be put into a floor. GFIs were designed for a specific use. So when they're being used for things that they're not designed for, it's a code infraction. For the most part, it's a code infraction. So we touched on that. So this is a good example. AFC, so arc fault, circuit interrupter, location requirements. They're pretty much required in every single location in your home, and it's easier to list the locations in which they are not required than it is to list the locations in which they are required. I hope that makes sense. There's more places where they're required than not. Fridge, kitchen counters, bathrooms, and a sump. And a sump has to be exactly as you see it in this picture. If it is not, it must be arc fault circuit. It must have an arc fault on it. Okay. Lights do not require arc fault, and hardwired equipment does not require an arc fault. Okay. So again, I use a furnace as an example. Okay. Unbonded receptacles. Okay. This is by far the worst job in the world. And as electricians, we hate this. When you have a 2-wire circuit or an ungrounded or unbonded system, an acceptable means to repair it is to put GFIs at the panel at the beginning of the circuit. Okay. If you asked me the science behind this one, I genuinely would not be able to answer it because I totally disagree with it. But this is an acceptable method in repairing an ungrounded system. Option number 1, like aluminum, you can tear it all out and redo it. Or option number 2, you put in a dead front GFI, or you put in a GFI receptacle. Okay, GFI breaker, also another option. But again, with shortages on materials, you're likely to see something like this. So, miswired receptacles, open ground, 2-wire systems is really common. Open neutral, literally a broken neutral. Open hot, again, that one's pretty straightforward. And reverse polarity, that just means that the wires at some point became crossed. Okay, again, this little nugget right here is probably going to be the most helpful tool because it's going to tell you all these things. And it's really, really easy. You plug it in, it'll light up, you snap a picture of it, call it a day. So, scorching. So again, something maybe was hanging in the plug or not plugged in correctly. You can tell this is a non-tamper resistant receptacle because it does not have the shutters. Tamper resistant receptacles typically are a lot stiffer and don't tend to have these issues. So it's kind of a double, it's a bit of a double win there, where sometimes it's like you literally have to force a cord or an outlet or a tester into it to actually get it to test. Inside cabinets, so there's a few defects here on this one on the right. Number 1, we mount electrical devices, so plugs and switches, in steel boxes or plastic boxes. And the reason we do that is because they are non-combustible materials. Wood is combustible, and therefore, if you were to put a box in here, the box would either have to extend right to the edge of the cabinet, or it would require what's called an arc guard or a spark guard. And it's a piece of plastic that slides inside the box and it mounts flush to the cabinet that protects the actual device screws from touching the wood. It's a fire hazard, and it should be in place. You won't be able to see it without the cover off. So in this application, I would likely just say, no cover in place, rectify, code infraction, whatever, something along those lines. So common receptacle defects, painted over. Again, electrical devices are not to be painted. That's conduit, panels, receptacles. You can paint a switch cover. You're not to paint a receptacle. Poor locations. This one looks like somebody built a fence over or next to it or whatever. Again, that's just common sense. I just note that the receptacle's in a poor location and inability to use or operate. I don't know that I'd reference a specific code on that. So, garage wiring, you are required to have one receptacle per vehicle. On an attached garage, you're required to have arc fault protection. On a detached garage, you are not required to have arc fault protection. So you'll find a lot of electricians will run a sub panel out to the garage, a 240-volt sub panel, and then they'll do the garage devices off the sub panel. No GFI requirements for attached in the interior. The exterior always requires GFI protection. So even though there's, for the most part, excess moisture in a garage, no GFI protection is required. One receptacle per overhead door, whether that's a side mount overhead door or a roof mount overhead door, it requires a receptacle. Safety sensors for each door. This is not actually an electrical code. It's a building code. And it doesn't matter how you meet the requirements of a safety sensor. It can be the air sensor on the bottom of the door where it comes down and detects the air and sends the air up to the actual controller, or it can be the eyes on the sides that read when there's something obstructing the view. That is not an electrical code, but it can be definitely noted in your electrical section. That's a building code. Dedicated circuit requirements. So I'll start off at the bottom. The central vac requires a dedicated circuit. Microwave, so a microwave or a microwave hood requires a dedicated circuit. If it is on the counter, it does not require a dedicated circuit. Okay, dryer, range, furnace, or electric heat. The exterior receptacles, typically the front and the back. The laundry room requires its own circuit. And the fridge. The fridge is kind of an interesting exception. A fridge requires a dedicated circuit, with exception that it can be on with a clock plug. So you'll find in houses that were built in the 80s or even the early 90s, in the living room or in the dining room, there's a plug that's up high, and it was meant for, it was meant for when, Wes or Mo, when you guys wanted to hang your clocks on the wall, you could plug it right into that outlet. That is acceptable to be on with the fridge. So outside of that, pretty much bank on the fact that the fridge is required to be on its own circuit, because we're not putting in clock plugs anymore, that I'm aware of at least. So again, extension cord use. This one's really straightforward. An extension cord is meant for temporary use. So even if you've permanently used it to run something and you've strapped it to the wall, or you've run it through a hole in the wall and made it into a permanent fixture, it is a temporary cable. It is designed for temporary use. It's not meant to be stapled, strapped. You can't run it through holes in the walls. Again, this is not so much an electrical code, but if it's frayed or damaged or pinched, it's more of a fire concern. And I mean, we may not take that very serious. We deal a lot in insurance jobs. And I attended a fire probably about 2 months ago, and they had a power bar behind their television, and they had a couple boxes off to the side, and the boxes were resting on, and it might have been the corner of the box, it's unsure because everything's completely burnt, but the corner of one of the like Tupperware boxes or something like that was sitting on the extension cord, and it was just sitting on it the right way or the wrong way. And the entire basement had a fire because that extension cord caught on fire. So it is a big concern, and it's definitely something that you need to be conscious of, through windows, those types of things. Again, they're not meant for permanent installations, so we really need to be conscious of that. Lights, wet locations. The lights need to be rated for the wet location. You can see a lot of newer houses, have these slim pot lights. They're really thin. They are rated for wet locations. An open style pot light. So this one's actually doesn't have a trim, but if it had the complete seal, like if it was completely covered, it would be rated for wet locations. Now, if it had the open style where you could see the light bulb, it's no longer rated for a wet location or a damp location. Water intrusion. Obviously, just be conscious that some devices or electrical equipment, may have water enter into them. We take precautions to make sure that water doesn't enter into things. But again, it's just something that you guys have to be conscious of and diligent in I guess, capturing in your inspection reports. Again, this bulb in particular is a wet location or an exterior rated bulb. And it clearly just had broken glass or a crack in it or something that's allowed water to enter into it. So again, I'm sure you've all seen this before. As soon as you turn on the outside lights, bugs are attracted to it and they just fill up. That's just improper maintenance, and can potentially cause fire. Overheating, a lot more common in incandescent bulbs as we're slowly making the change to compact fluorescent or LEDs. It's becoming less and less of a thing. That being said, LEDs have electronic drivers in them, and surprisingly enough, they give off an immense amount of heat at the base, which has changed from traditionally when you went to grab the light bulb before, if you grabbed it on the end, your hand would be toast. But if you actually grab the light bulb on the base, it would be warm or less hot. With an LED, because there's a driver in the base is what gives off the majority of the heat, and the outside casing is actually just plastic that disperses the light, and the actual filament is on the base of the interior of the light bulb. So not so much a concern anymore, but just be really conscious on the bases more so when you're looking at lights, because that's where the majority of the heat's coming from. No protection. This is technically an acceptable method. It's kind of an odd one because a light has to undergo CSA approval or Intertech approval. This fixture is likely approved to be like this. It's not uncommon to see fixtures specifically like this in restaurants or houses. We get these new like homemade lights, things to watch out for, and just looking for a sticker of approval on something like this is not a terrible idea. Typically, you'll see them right around the base here or up top around the edges. And again, I don't think the expectation is that you're going to catch that. But a lot of times, more concerned with lights in crawl spaces that are extruding into the basement or the crawl space and are not protected, because that's where you're going to, smash your head on them or move something in a crawl space or the basement, and you're going to hit them and they become a bit of an obstruction. This one in particular, I probably wouldn't be so concerned about because it's likely above an island. So not weather tight. Exterior lights require a seal, and then obviously a proper box. This one looks like it's been kind of, I guess, jimmy rigged in I don't even know what they've attempted to do here, but it needs to have a box. It needs to be properly sealed. If you can't seal it properly with what the components that are supplied, just some silicone would be adequate. But again, just note it in your report that it's not sealed because you're going to have water intrusion in there. Recessed pot lights. Again, recessed pot lights are kind of going to the wayside. We're moving more to slim LED pots, which don't actually take up any space in an attic. And the biggest thing to look for here is a marking called an ICAT, I-C-A-T. And with an ICAT, it's an insulated can, so it's rated to be next to insulation, and it's airtight. Again, if you're up in the attic, just shuffle some insulation around, see if you can find a pot light, and you should be able to read that it says ICAT. If it doesn't, you're going to see something maybe like this. Do not install insulation within 3 inches of this fixture. That is not an insulated can. It's not rated to be adjacent to insulation. So this may be an AT can, maybe airtight. It's unlikely, or it might just simply be a pot light can that's not rated for insulated ceilings or exterior walls or exterior ceilings. So if you have a pot light that looks like this on the right, one way to rectify that is to install a poly hat. It's good practice anyways. Again, I think the most important thing in your home is your vapor barrier. This is typically what we use. There's smaller versions of this that are, I don't know, probably about 6 inches by 24 inches or 6 inches by 12 inches. But again, pretty straightforward. Again, this is not actually an electrical code. Having smoke detectors is actually a building code requirement. Electrical inspectors like to call us on it, but it's not honestly up to them to do so. I would maybe actually mention this in your building section or your general section if you have one. That's entirely up to you though. It's based on jurisdiction. Alberta Building Code requires smoke detectors in all bedrooms, and then smoke CO detectors on each floor of a house. They're required to have battery backup, and they're required to communicate with each other. Okay, they are not allowed to be on an AFCI circuit, and they're not allowed to be on a GFI circuit. Interconnectedness, like it. They're required to be interconnected, and they must be on a lighting circuit. So that is an electrical code that they're on a lighting circuit. And the intent behind this is you realize when your lights go out, and then you'll know your smoke detectors have gone out. If you put them on a plug circuit, you may not notice that the plugs in your living room stop working. So that's the intent behind that code. That's a really easy check. And I mean, for testing smoke detectors, there is expiration dates on them. I can honestly say probably 50% of the homes that you will inspect, they have expired smoke detectors. You can simply take a smoke detector, twist it, flip it around, and you'll see an expiration date. Okay. I'm fairly certain, Alex, I don't know if you can speak to that.
That's a very generous 50%, Jesse.
Yeah, I was going to say, I'd be impressed if it was 50, but yeah, it's, they don't last very long. And when they sell them, I think they've got 7 years lifespan or something like that. And when they sell them on year 5, It really it really limits the time that you actually have for that smoke detector. So yeah, just something really easy to look for. It may still function. So I mean, you could do a function test and then flip it over. But just something really easy to definitely, absolutely, John. Yep, call out expired smoke detectors. That's I mean, I guess to give you an idea, again, we do a lot of insurance work, and most of what we do is lightning strikes throughout this time of year. And we'll go into a home and do an initial inspection, and we'll provide a report to the insurance company. And part of that is you know, we found issues with the well, and we found issues with the phone system or whatever it might be, and that's it. It may be specific to one area. And part of our report to the insurance company is we want to check the well system, we want to check the phone system, and we want to check the smoke and the smoke CO detectors. And they come back to us always. And they say, well, why the smoke CO detectors? And I say, well, if there's a fire, that's going to tell them that there's a fire. So if you're prepared to carry that liability of not checking them and just hoping that they're still working, then that's fine. If you know, don't check a plug and the plug has reverse polarity, that's one thing. But if you're not checking the smoke detectors and the smoke detectors don't function properly and they have a fire and they go, well, it wasn't in my inspection report that they weren't working, or that they were 3 years expired, or they were 10 years expired. I mean, that's definitely something that you want to make sure that you're checking. That is entirely based on the situation, John. As an electrician, I've worked on the buyer. So he asked, who's responsible to replace the expired smoke detector, the buyer or the seller? That is entirely up to the buyer and the seller. So a lot of times what happens is I get a copy of an inspection report from a home inspector, and a realtor will call me and say, hey, what's the price for this? And we'll put together a price for all the repairs. So maybe it's just changing the smoke and CO detectors. And the homeowner says, well, I'm not going to do it myself. So the seller is like, I'm going to do it myself. That's okay. You absolutely can change out smoke detectors yourself. There's nothing that says you can't. It's actually really easy. Maybe the seller's like, no, you know what? I just want $200 taken off my sale price. And I want that, you know, bare rug in the living room, and then that's it. And I'll deal with the smoke detectors myself. So every deal is going to be different in terms of who's paying for it or who's doing it, or you know. So there's really no hard set answer on who is responsible for that. I mean, it's just it's something you should note in your report and then leave it up to them to deal with.
I'll make a couple notes there, Jesse. So with these alarms and the detectors, so the typical lifespan is 7 to 10 years, but I always tell my clients, just get new ones. Smoke alarms are 2 for $20, super cheap. Carbon monoxide detectors, 30 to 50 bucks. You can buy combination units. You don't know what kind of stresses these alarms have been under. Have they been painted over, or were they, you know, were the sellers like terrible cooks? Did they have a bunch of kitty litter boxes, or was the package of the alarms, you know, stored in their garage for 2-3 years? So I mean, for $100, you can save proof your house and your family, right? So like I said, that takes even more liability off you, because then it just says, it puts the onus on the buyer, the potential new owner of the house.
Yeah. I mean, the biggest thing is you've checked it as a home inspector, you've done your due diligence, and I mean, that's really it. You've noted it in your report, they're expired, or I hit the test function button and they didn't run through their cycle of testing. So that's where your responsibility ends. Hot tubs. Hot tubs are an interesting one. Most municipalities require that the permit be pulled by a licensed contractor. Yeah, I mean, so that's a quick check. Is there a sticker on the panel? They require GFI protection, and like any sort of electrical installation, they're required to be bonded. Okay, saunas must be on a timer. Okay, each municipality is going to be slightly different on that as to the maximum amount of time. For the most part, they are an hour at max. Okay. Oops, sorry. Mobile and modular homes, the bane of my existence. They don't, for the most part, on the actual installation, they do not require an electrical inspection. Okay, most modular or mobile home builders go and get the capabilities to CSA approve the house or the actual home as a CSA approved product. And so what that means is a modular home is built and inspected in a very similar way as to a TV or a VCR. That TV has a CSA approval for that TV as a complete component. Okay, a modular home or a mobile home is built very much in the same way. It's built in a facility, and once it's done being built, they say, yep, CSA approved, and it no longer requires an inspection. That being said, the service that feeds that house, because it is not part of that CSA approval, requires an inspection. Okay, there is special rules pertaining to mobile and modular homes, and it's important that you understand what they are. And for the most part, they don't follow any other codes. That's why not fond of mobile or modular homes for that reason. They get away with things that are not code. But again, it's a little bit, the rules are a little bit different. So just be conscious of that. Just be conscious of that. And yeah. Apartments, townhouses, and condos. There's several different ways to wire an apartment. You can have a panel in each unit. You can have a panel, you know, at a mechanical room. You know, there's different ways of wiring condos and townhouses. I mean, as of currently, most of the newer ones, you'll find panels are inside of the unit specifically. The catch is if the panels are not located in the units, each tenant requires the ability to reset their own power. So if the panels are located in a hallway, closet, or wherever that might be, they are legally required to have access to reset their own breakers. So yeah, no main disconnects prior to 1980s. That's not uncommon. And the neutral bonding of the enclosure is not present either. Yeah, so electric vehicles, I believe this is outside of your normal scope, Alex, as to what's required of you guys.
That's correct. Yeah, this is just for knowledge because they're going to be a new thing. It's reality. So
yeah, so electric vehicles are interesting. We just actually installed our first Tesla one about 6 months ago. They take any amount of power. There's not specifically like a 15 amp Tesla charger or a 30 amp Tesla charger. There's not a 120 volt or a 240. It's whatever power you put to it, it's going to use, and it's going to charge faster based on that. I mean, there is two different types. There's one where it's got the actual charging unit inside of the vehicle, so it plugs into a standard outlet, like this one here on the left, or it's got hardwired power, and then this charging unit actually plugs into the vehicle. So this is very similar to a Tesla one. This would be similar to like I think it's like a Chevy Bolt would plug into something like this. Volt or Bolt? I think it's a Volt. Anyways, similar to a level 1 charger. I've got a hybrid that I drive. It plugs into something similar to this. So again, generators. I can kind of touch on this. For the most part, it's important that generators have transfer switches. It's an independent unit, and all it does is it allows the transfer of power from generator to utility power, and it limits the ability for power from a generator to go out to the back into the system, the power lines, because you end up putting power linesmen at risk if you allow power to freely go back onto the lines. Excuse me. Accessibility equipment, it's like elevators, equipment that rides up the stairs. To be honest, we don't deal in elevators. We provide power for them, and then elevator mechanics really are the ones that are, digging a little bit deeper into that. If you run into a house with an elevator, just recommend that that they get certification documents, because an elevator should be certified annually. Renewable energy systems. The best advice I could give you for, solar or wind or micro hydro is bonding. Make sure that it has proper bonds and make sure that it has the ability to shut off. Okay. Exterior solar installations that have battery backups are required to have a giant red button that you can smash and turn the whole thing off. And it should be adequately labeled. Batteries, having the ability to turn them off really easily. Having a bond to them, a clear, visible bond wire to these systems is absolutely imperative. Okay. And yeah, a big thing is for specifically for your accessibility equipment. So elevators is just third-party inspections. So I don't inspect elevators. You shouldn't be inspecting elevators either. So yeah, again, solar installations are becoming more and more common. They are, they're great. There's a lot of grants out there for them. But again, just making sure that the bonding is in place. Outside of that, I mean, they're just a really great add to a house. So permits.
I can talk about this, Jesse, a little bit. So guys, this is mostly to bring up that, again, as home inspectors, you guys are not required to know any of the codes that we've been presenting to you in the last 5 days. They're just here for your knowledge so you can become better inspectors and inform your clients what should and should not have been done during any renovations or any sort of builds. So again, you're not required to check for permits, but as we've been chatting today, especially with electrical, because it's one of the easiest ones to find. Like Jesse was saying, typically at the panel board, you're going to see the inspection decal from the municipality. So again, when I do my inspections, there's a lot of clear signs that you're able to determine that, say, the basement wasn't built or developed by a qualified electrician or even contractor. So things like we've been talking about, the requirements for smoke alarms, right? If you guys go to a house that was built in the last year or so, and you go to the basement and all of a sudden there are no smoke alarms in the bedrooms, that's usually a pretty good sign that it probably wasn't permitted and there probably was no qualified electrician that did the electrical work. Same thing with AFCIs. Now they're required in the bedrooms. They have been for about 15 years, you probably think, HSE, for AFCIs. So again, if you're inspecting a house that was built in the last 10 years, then you go to the basement, we got bedrooms with no AFCIs. Again, that's not the clear sign. Or if you're going outside and you're seeing AC units with no decals, if you're seeing hot tubs with no decals, these are things that you can choose to bring up. I always do, because I know that if I was buying a house and it turned out there was no basement permit for the development, depending on how long it's been since that development was completed, depending on the safety codes officer, the current owner or the potential new owner, which will be your client, may have to got up the entire basement to show them the actual wiring, right? The roughing and the final installation. So again, it's up to you if you want to open up the can of worms, but I would recommend you at least consider it, just because your clients may be very, very thankful of you. There are some buyers that are are by the book, every little thing, right? If there's something that's not to code, they just say, you know what, who knows what else is going on with the house.
Yeah, and I mean, there's no harm in if you guys are going to go out and you're going to create your own reports and use your own programs, and there's nothing wrong with having a line somewhere in the general information area recommending that they request all permits on the residence. It's really, really easy for me to call as a homeowner to the city and say, hey, I need a copy of all the permits that were pulled, or what they were pulled for, or whatever. And it'll be really clear that if I have a finished basement and there's never been a permit for a finished basement, I mean, that's really easy right there. I will read you guys. It's the third code in the electrical code book. So it's literally called permits. Okay. It says electrical contractors or other responsible for carrying out the work shall obtain a permit from the inspection department before commencing work with respect to, and now here's where you need a permit: installation, so anything new; alteration, so anything that changed; repair, so anything you're fixing; or extension of any electrical equipment. So anytime you work on an electrical system, you have a permit, no exceptions. Now, there are certain municipalities that have made exceptions to that, and they're covered typically under a bulletin or under the provincial guidelines, whatever that might look like. But there is exceptions. In Alberta, we're allowed to, do retrofits of lights without pulling a permit. It would be really ridiculous if we had to, pull permits for everything. But again, hot tubs, basement developments, things you guys are going to, kitchen renos, things you're going to run into often. You walk into a house that was built in 1970, and the first thing they say to you is, well, we redid the kitchen last year. That's a flag, right? Note that in your inspection. It is imperative they have permits, because ultimately what's going to happen, again, as someone who deals on the restoration or the insurance side, it's quite often we get called into a home or a basement where there's been no permits pulled, and they went to add a hot tub. Inspector walks in and says, well, hold on a minute. I looked up the permits on this house and there's no permit for a finished basement. And now that homeowner is responsible for bringing that basement up to current code. So it's a really, really small thing to note, but it's just another thing to kind of cover your butt and to cover the buyer's butt, just to make sure that, they're covered and they're not going to be responsible for thousands of dollars to do a repair.
So Jesse, if someone has done some renovations and they have to get permits, the people giving the permits want to make sure that you're licensed in doing that. Say you're redoing all your electrical work, you want to make sure the guy's knowing what he's doing before he starts getting his hands full, right? Is that kind of what they're looking for?
Yeah, so there's a couple exceptions to that. In Alberta specifically, okay. In Alberta specifically, there is a few things that you require the services of a master electrician. So I'm sorry, I don't know who is speaking, but
Cody, sorry.
Okay, Cody, no worries. So Cody, if you owned your home, you are well within your rights to pull a permit on any renovation you do. You can pull a permit on anything, with exception of anything to do with an electrical service. You require a master electrician. Mm-hmm. Anything to do with a hot tub, you require a master electrician. Okay. You want to renovate your basement, you can pull a homeowner's permit in Alberta to renovate your basement. It still has to meet the same code requirements that I do. And I'll be entirely honest with you, inspectors hate it when people do, like electrical inspectors hate it. So they will make it hell for homeowners if they try and renovate their own basements.
Yeah.
So again, honestly, as you go along through your inspection journey, as you guys see these major code infractions, you know, it's things like having extension cords being used or having openings in a panel. Those are things that electrical inspectors will never, ever allow to stand. You know, you pop open a panel cover and there's holes in the panel and there's a brand new basement. I promise you there was no permit pulled because of the fact that an inspector is going to come in, he's going to open up that panel cover and be like, this is not acceptable. That is very unsafe and it needs to have panel covers in it, or there needs to be knockout fillers, or, you know, not having GFI protection in a basement bathroom. Those are the triggers that that are going to help you determine whether or not a permit was pulled. But we all have to meet the same codes, whether it was you, Cody, that did the work, or me, or one of my electricians. We're all held to the same electrical code book.
Well, I'm sure me, along with everyone else, like when I'm buying a home or whatever, I wouldn't want a guy that's been doing electrical for 3 weeks, you know, want the, you know, do my basement. I'd want the guy doing it for, you know, 5 or 10 years, right? The guy with experience. So if I'm buying a home, I want to make sure it hasn't been renovated by some buddy down the street, right?
Totally, absolutely. And I mean, I'll be honest, like I employ one electrician. He's a 4th year and he's probably the best damn electrician I think there is out there. And I would at this point, because I've not been in the field for so long, I would send him to your house before I do it myself. Right. And it's just, you know, but you're absolutely right. You're absolutely right. But again, keeping in mind, like the quality of work is not necessarily going to be there, but the code requirements are even across the board.
I would
right?
just hate for something to happen, right? Like be an issue because someone didn't know what they're doing is my only safety concern, right?
Yeah. And I guess if there's a permit that's been pulled, just have the, I guess, the confidence that that homeowner, if they were the one that did it, likely was being held to a higher standard.
I'll make another note on that. Cody, unless you have some follow-up questions to Jesse.
No, you're good, Alex.
Okay. Yeah, so the follow-up to that, again, guys, you don't need to bring up the code stuff, the permit stuff, by all means, but if you do choose, be very mindful because, you know, some inspection decals will typically have rough-in, you know, it'll have a little bracket saying rough-in, and they'll have, like Jesse said, the SCO's possible name or their possible, you know, employee number. It'll have the date, and then also typically say what has been done: basement, service upgrade, you know, AC, hot tub. But at the same time, you'll come across strange permits. Well, they might say exterior receptacles only or basement lights only, right? And then the basement still develops, so you might go, well, that's really strange because it doesn't talk about the bathroom, doesn't talk about, you know, the smoke alarms, and you know, I'm not seeing these things. So again, just because you might see the final inspection decal, you might still say, you know what, something looks weird. It's, again, I think it's better for you to err on the side of caution, and then, you know, have the seller or the seller's agent kind of, you know, slap wrist to, hey, well, this was fine, but at least you know at that point, okay, well, that was my mistake, but at least, you know, I've cost sellers tens of thousands of dollars just because, you know, it was a partial permit that was pulled and they didn't, the contractor didn't decide to do the full permit, right? And now, again, like, drywall's got to be ripped open, so.
Yeah, better safe than sorry, and there's no reason not to ask, right? I mean, that's kind of why I say, just if you're doing your own reports or if you're using a program, there's nothing wrong with just creating a you know, a line that's in there, like recommended that all permits for any work done in the last, you know, 10 years be produced or something like that. There's no harm in that. Again, it definitely puts a little more work on the buyer and the seller, but again, it kind of covers your butt, and at least you've recommended it. John asked 2 questions. I'm going to answer question number 2 first, John, because it's the easy one. Number 2, when does a stairway to a basement require to have it's actually called a 3-way switch, which again is a kind of a weird thing because it's only 2 switches, but it's called a 3-way switch. You called it a two-way switch, and that's okay. When's it required to have a three-way switch? Always. Okay. The intent of the code pertaining to light switches is that if you're using a stairwell, you have to use a stairwell when it's lit. So whether you're starting at the bottom in the morning, you have to be able to turn on the lights of the stairwell, or whether you're starting at the top, you have to be able to turn the lights on from the top. So always, a stairwell always requires a three-way switch, a switch at the top and a switch at the bottom. Okay. Question number 1, can you shed more light on how to identify grounding among those pipes running underground near the electrical meters? Honestly, your best bet is to look for it inside the house. A good rule of thumb is on the outside of the house, if you see a smaller conduit, typically a 1/2-inch conduit, it's about the size of a volt tick, okay? You'll see that running down. If it's a 1/2-inch conduit, it will not be anything but a ground, okay? There's nothing else that uses a 1/2-inch conduit. Now on the inside of the house, you'll see either bare copper or you'll see green cable coming out of the panel. And when we use grounding cable or bonding cable, so number 6, it's extremely clear as to where it's going. So it'll come out of the panel and it'll go to the gas line, and you'll see maybe one come out and it'll go to the water line, okay? And then you'll see one come out and then it'll just disappear. The one that disappears is likely your ground, okay? This is really not something that I would stress on too much, because it's like the number one thing inspectors look for on houses that are probably post 1980. So that's not so much something that I would get super hung up on. I'd more be concerned about the bonding of the gas line and the water line, because those are the things that get missed even by some inspectors. Okay. Yeah, no worries. Electrical theory. Alternating current. Yeah, we can talk about this if you guys want. I think this is kind of like an option.
Yeah, this is just basically a little time filler, if you will. We only have two slides, and again, this is all theory stuff. Never hurts to hear it a few more times, just because it can be a little bit confusing. So.
Okay, so this is in a nutshell, and this is actually really helpful because we can talk about phase A and phase B again. Okay, so electricity is on an axis. Okay, I don't even know which one X and Y. It doesn't really matter.
Jesse, do you want to draw on the PowerPoint? You can draw. You can actually turn on a pointer. You can literally mark on a big white space if you want. That's easier.
What?
Yeah. Yeah.
What is this sorcery?
No,
Annotate?
I believe you right click and then it'll.
Oh no. Here we go. I found it already.
You got her.
Okay, here we go. Let's try this. Oh my goodness.
I'll send you the bill.
All right. Sorry, everybody. This is new to me. Oh my goodness. I need
Yeah,
this
the
all the time.
exterior fellow was really adamant on using that pen quite a bit there. So
Very good.
He was a very good drawer. Yeah.
You could have told me this at the beginning of the course. I would have been all over this.
That's why I didn't.
Okay. I gotta figure out what I'm doing now. Okay. All right. How do I undo? Okay. Perfect. Wow, this is great. That's you're having a good week when drawing on Zoom makes your day. Okay, so electricity, if you think of it on an axis, alternating current does this. It's a sine wave for those of you that love high school math, okay? So again, this is sine wave. What it does is it takes an average of what's here, and it says, okay, whatever the peak is to here, we're going to take an average, and that's how we end up with 120 volt power, okay? So it does this 60 times in a second. So it goes here, down, back up, okay? A rotation, a hertz, to 60 hertz in a second, okay? So this would be phase A, okay? Now phase B is going to be opposite of that, okay? And this is where it comes in that it's important that you're not on the same phase with 240, okay? Because what happens is phase B does this. Oh dear. All right, I'm new to this. Don't judge my art here. Okay, so the difference between A and B, okay, this is B, this distance right here is what gives us 240. Okay, now if you were to put them on the same breaker, you'd end up in a situation where you've got this, okay? Okay, now they compound. So now you've got 120 plus another 120, and it's not an issue for these lines, it's an issue for the neutral, and you end up putting way too much current on the neutral, okay? So again, this is really not something that you guys need to know, but it's kind of the science behind why a 2-pole breaker is so important and why it's so important that it's on alternating phases, okay? DC current, which I'll be honest, is not my strong suit. If you need to know about DC current, talk to a mechanic, is like this. That's DC current, okay? It's constant, it's direct, it doesn't alternate, doesn't change. It's 6 volts, it's 6 volts, it's 6 volts. It's always 6 volts. If you could track AC current, you'd actually see it go from like 177 down to 0, then negative 177, then back up to 0, and then positive 170. So direct current, you stick a power meter on there to track the power, it would be 12 volts for forever, just constant. Okay, it doesn't change. So again, really not stuff you guys need to know, but if you want to take a picture of that and I don't know, get a printout, put it on your wall, you're welcome. I can sign it if you'd like.
Thanks, buddy.
Shorts. Oh, great. Now, how do I get rid of this?
There's an eraser function.
Okay, here we go. Let's go. I'll go like this. Okay, okay.
What was the exterior guy's name, Alex?
Daryl Paul.
Daryl,
Yeah, he's
right,
with the Alberta Siding Contractors Association.
That's right. Yeah. You're actually holding up to Daryl's standards there, Jesse. So good work. He's a pretty good drawer too.
Thank you. I honestly, I printed that page out. I'm going to post it somewhere. So, short circuits. I mean, this one's pretty easy. You get short circuits, you know, when you've got wires touching. I mean, it's that aren't supposed to be touching. Hot to ground, hot to neutral. Hot to to ground, whatever that might be. That's what's going to cause short circuits. I mean, it's going to take electricity, like anything, is going to take the least path of resistance. And sometimes that's you, sometimes that's a ground. And again, that's why we have breakers in place, because breakers are intended to trip on a short circuit. So ground faults.
Maybe I can just make a quick analogy. So guys, you know, the way your electricity is ran, it's supposed to go through your appliance, your fixture, whatever it is, it's supposed to go through resistors, slow it down, right? At a modulated, I guess, rate, if you will. A short circuit is if you have, say, that bare wire, say you for whatever reason, you decide to pull out the Lumex right out of the panel board, and it's live, and you just take it right to the anything that's grounded, whether it's a bonding conductor or say you got a ground pin sticking on the concrete floor, and you just go, that's a short circuit. It's basically bypassing any resistance, just going straight to ground. And like Jesse was saying, if the overcurrent protection device, whether it's a break or a fuse, was working properly, it should shut off, because there's going to be a lot of energy going through those conductors. See, this is why I didn't show you earlier.
So if this comes into contact over here, we're going to end up in a situation where there's a short. Okay. Normal operation is going to be this. You know, we've got 120 coming into a motor, and then out of the motor, it's going to go to the neutral and back to the panel, and it's going to make its regular cycle. Okay. It's passing through a load, and the load is using what it needs to operate. In any situation, if we've got a broken wire or something going on right here, it's going to make a direct connection to whether it's the neutral or whether it's a ground, and you're going to end up with arcing in this area right here. Okay. Oh, there we go. That's easy. Ground faults protect against leakage current. It really is measuring the difference between the hot and the neutral is what it's doing. Is it saying, hey, we put out, you know, X amount of power, so let's say 10 units of power, but we only received 9.8 back. There's something wrong, and some of the current's going missing. Where's it going? And then it's going to trip. So in a nutshell, all it's doing is monitoring what's going in and what's coming back out. And that's why it's so important that that neutral that comes back from the circuit is tied onto the breaker, because the breaker is effectively monitoring what's going in and what's coming back. So that's a pretty simple analogy of a ground fault. Again, understanding the science behind it is not really that important, but again, all this is doing is it's redirecting some power to that ground and saying, we're going to redirect some, and we're going to make that GFI think that that there's some power missing, and it should trip. So, and that's the end.
Awesome. Thanks so much, Jesse.
That is the end.
Thanks, Jesse.
Any questions, guys, for Jesse, whether it's from an electrical standpoint or even remediation? Because again, Jesse does have a couple companies, and you know, if you guys are in the Central Alberta, Edmonton, Calgary area, by all means, you can take Jesse's information.
Oh yeah. Put that in the chat.
Yeah.
Okay.
Thanks, Jesse.
Not a problem.
And thanks, Alex.
Yeah, no, absolutely, guys. Absolutely.
Yeah,
So,
great week.
glad you guys found it useful and beneficial. There you go.
Do we have
So
any
if you-
more courses or classes or anything like that coming up, Alex?
The next ones will be in October, late October. So with all these sessions, again, if you guys missed any portions of it, or if you want to watch them again, they should be available probably mid next week. So if you want the recorded link, just send me an email. They will be on the website, but they're on a hidden page just because we don't want, you know, people that shouldn't be learning this stuff. But again, this will all be available. Yeah.
So I put my information in the chat if you guys want it. Again, if you've got questions, you're welcome to text me. Again, electrical related. Typically, if you can include a picture, that'd be great. And again, we, like I said, or like Alex had mentioned, we own an environmental company. So if it's related to asbestos, mold, radon,
Bodies too?
fentanyl, what's that?
You guys do bodies as well?
Yeah, fentanyl, trauma, any of that sort of stuff. We've got a team member that can help you out with that as well. So
Awesome. Yeah, and if you guys don't have any questions, by all means, you can log out, and like I said, let me know if you want that link.
Yeah, I'll definitely grab the link from you, Alex. I'll run through it again just for more knowledge, I guess, if I missed anything. So.
Absolutely, yeah. The more times you guys watch and listen,
That's
the more
right.
you learn. So
100%. So I'm all about that.
Thanks,
Okay.
Jesse, and thanks, Alex. Have a great weekend, guys.
Thanks.
Yeah,
Jesse.
thanks, Jesse, man. It was awesome.
Have a good week,
Would you like to share all the recorded video on like the Google Drive or something and share with us?
no, it will be like I mentioned, Amir. We're gonna upload them on our website on a hidden web page. So just let me know if you want the link, and we'll send it to you. And they'll be up usually for about 6 months. Like we still have the January sessions, but we're gonna be taking those off as we get newer information out.
All right, I take your instruction. Thanks.
Yeah, no worries at all.
thanks, Wes.